He's very knowledgeable and he loves what he does. You can see the passion will come out when he speaks. And he continues now serving the dental community as a Zirconzon ambassador and a branch manager. Okay, I'm gonna leave it over to you. I'm gonna disappear now, but I've been following your lecture with attention, Kevin. And what I will do is, guys, I will remind you if there's any questions, you can ask them, and then I will moderate them at the end. But I will send you a chat to remind you if you have any questions. Please put them in the chat, and then we'll discuss them later. Okay, Kevin, it's all yours, buddy.
Thank you very much, Ettore. Thank you, Bahar. And thank you all. Good morning, everyone. First thing, I'd like to thank Bahar and Ettore and their team for organizing these meetings. They've been a big advocate of knowledge and wisdom. We all thank you, Ettore and Bahar. And hello, everyone. And thank you very much for joining us in this beautiful Saturday morning. Hopefully, in this morning, you all will have some more knowledge about different topics my colleagues will present. And hopefully, we have a productive Saturday and you have the afternoon to have fun. All right, without any delay, let's talk about digital dentures. It's a very hot topic these days. And I can tell you guys that in the last 3-4 years, we've been advancing in different aspects of digital dentures. As Ettore said, correctly mentioned, the technology is right at the peak of its height in terms of milling machines being their most accurate and the fastest speed possible. 3D printers are a lot better, although there's a little bit of room for improvement. There's always room for improvement. But material is something that we are advancing every day. And that's where we see a lot of changes. Also, in data acquisition and where you gather data from the patient, that's where we can improve. We can improve a lot of data gathering right before the designing. So today I'm gonna talk about some of the tools that we have at Zirconzon workflow to help clinicians, denturists, and dental technicians gather data in a more efficient and more accurate way, which in a sense will help you guys to design a better and more accurate restoration at the end of the day. Okay, so let's see what we have today. Ettore was kind enough to introduce me so we can pass this a step together. First, a little introduction about Zirconzon for those of you that don't know Zirconzon or know little about it. Zirconzon is a dental technology-based manufacturer. Mr. Enrico Esteger, the founder of the company, is a dental technician himself. So everything that we do at Zirconzon is for dental technicians and clinicians. We are not a side branch of a company that been in different industries or different aspects. We are a dental technology company. We produce every component of this workflow in our facility in South Tyrol in northern Italy. And I have a quick video that we can watch together. See if I can get the voice going back. So we do produce our own scanners. Let's talk about the digital components that Zirconzon offers. We have our own scanners, intraoral and desktop scanners, and a face hunter, which is a tool to gather information, extraoral information of the face of the patient. We also have archive, which we register all our cases. We have 2 software for design, modellier, and modifier. And we have a nesting software, which help us nest the parts that we design. And in the end, we have machines, milling machines to produce the design SDA file. We have offices. We started, as I said, the company started in South Tyrol in Italy. And then it grown very fast in the last decade. Now we have offices across Europe and North America. We have our Canadian office as well as Atlanta, California, and New York office in North America. We have office in Mexico and South America. And the main offices are still in Italy, in South Tyrol. We also, as Ettore said, we've been always, Mr. Steger and Zirkonzan, a big advocate of education. He started military schools, and by saying military schools, some people think that he teaches people how to use gun. No, the weapon here is knowledge. That's why he calls this places military school, because he believes that knowledge and discipline should go hand in hand. And the knowledge without the discipline to use that knowledge can be toxic. So he created these military schools. Now we have Safari School, Forester School, Forge, and other schools where he invites talented and skilled dental technicians or students, dental technology students from different parts of this planet. They spend a week in these facilities. They improve their knowledge of dentistry. On the side, they do some other activities, non-dental activities as well. They make cheese, they do community service, they go running in the morning. As you can see, they even make their own name tag. At the end of this course, which is 1 week, they are registered soldiers. They get certificate, and if they are picked by their teachers, if they show talent and extraordinary skills, they'll be picked for Ranger schools. Ranger schools is a higher level. The course is about 45 days, and at the end of it, they become Rangers in dental technology. That means they passed all the advanced courses of dental technology. They can start and finish a job, not only in digital, but finishing it by hand, meaning that you finish, whether you design a denture or a crown and bridge restoration, at the end, you should be able to nicely finish the job as well. So that's about the military schools. If you have any questions, please let us know. Ettore, Bahar, and myself, we would be happy to answer any questions that you have about our schools as well. So this is how our digital workflow looks like in Zirkonzan. So everything starts with archive. You can see on the left side an icon with A. That's where we register the case. Okay, this is like a database where you bring the case in, you register it, you can define the case, you can say, okay, I want to do this and I want to do that. You can have different treatments for the same patient in our archive, by the way. On the scanning side, as I said before, we have our desktop scanners, and recently we added an intraoral scanner, which is Health Canada approved as well. If you have any questions again regarding our detection eye or intraoral scanner, please let us know. Then we get to the planning and CAD software. We have implant planner to actually define your implant cases, to design your surgical guide with this software. Then we have the Modelier software, which includes all the different modules for fixed and removable restorations. Then we have Partial Planner and Modifier. Modifier is a recently added in-house CAD software. I'm going to show you a little bit about Modifier and what you can do. For now, Modifier is only capable of designing tray, custom tray, partial denture, full upper or lower denture as well, and all crown and bridge restorations that are not based on implant. Soon we will have the final version, which will include the implant restorations as well. And we have on the nesting side, we have our CAM software, the software that helps you nest the design part, and create an NC file for your milling machine, which we call nesting. One thing that I like to mention here, and this is a myth about zirconzan, which still goes around. Zirconzan is not a closed system, although you can buy every component of this workflow together and keep it closed, meaning that you use this workflow and you use this type of files that you create inside this workflow, which is only used in zirconzan workflow. There's another way. Our system can be purchased bit by bit, part by part, and as an open system, meaning that you can use our scanners and produce open file, STL file, OBJ, and PLY. At the same time, you can use our software, design software on its own. So you can have modular and modifier and implant planner and partial planner without having the scanner from zirconzan. And so on. You can have our milling machines and nesting software as an individual entity and use it in your lab for, if you have your own design software and you think, okay, I'm used to my design software, but I really like the zirconzan machines. They're very good quality machines that last forever, basically. So I really like to have the zirconzan milling machine without the need of any other part of this workflow. That is possible these days. So again, if you have any questions about different parts of this workflow and you need to know more, just contact me or put your questions at the end of this webinar. Now, this is how we start a case. This is archive. This is how archive looks like. So as you can see, you can define the case. You can add your scan data. You can bring your 3D and 2D pictures into the file. Okay, 2D pictures you can take with your phone. It helps you and your patient have a better understanding of the outcome that will come at the end of their design. So without even getting to the production, now with today's tools, you can actually have a really good prediction of how the outcome would look like just by using digital tools that we have today. So I'm going to show you a little bit of Face Hunter, scanner that we use to scan the face of the patient, a skull anatomy of the patient. And in our software, you can align the extraoral scan of the patient with an intraoral scan of the jaw. That gives you everything that you need to correctly design any type of restoration, especially the full arch restorations, especially if your patient lost a little bit of vertical dimension due to poor dentistry, poor hygiene, or any other reason, an accident. Sometimes you lose that valuable and crucial data of vertical dimension and how much you need to open the bite. These things are possible by using the Face Hunter in combination with our intraoral scanner. So I registered the case as an upper and lower denture in our archive. We continue. This is how our scanning software look like. This is our scanning platform. It works with our Face Hunter. It works with our intraoral scanner and desktop scanner. Here, I like to call it a virtual plaster room, because it's here where we gather all the information that we have in a virtual world. All the scans can be added here. They can be virtually mounted in our virtual articulator or any other default articulators that we have approved in our software. You can align and match pictures together or scans together. So basically, this is where you put all your scan data. This is the beginning of the process of the design, where you gather all the information that you require. As you can see, our patient went through a session of the Face Hunter. We gathered information about his face. And this is the Face Hunter. On the right, the device that you see on the right is the Face Hunter. It's not just a camera, it's a scanner and a camera. There's a difference between a scanner and a camera. The camera, you can use your phone to take a photo, but it doesn't mean that this is a three-dimensional photo. A scanner can produce a three-dimensional a picture of the patient. On the left side, we have our plane system. To make it easy for you guys to understand, it is a digital Facebook. It is our version of the Facebook. But why we use plane system and not a Facebook? There are different concepts when it comes to registering the occlusal plane of the patient. All of them are right and correct. There are some disadvantage and advantage which each system of a plane system that we have in dentistry. The plane system that we use works on natural head position of the patient. That is where the patient's head is in the most naturally positioned that the patient spends most of his time in. That means that they are not forcing themselves to be in the position to take this data off their face. The Facebook, on the other hand, is taken when the patient is on dental chair. That is not a comfortable position for the patient. The other problem that we have with the Facebook is that a Facebook is a symmetrical device. Our anatomy, although we would like to think that we are very symmetrical, we have two eyes, we have two ears. You can have an imaginary line going through in the middle of your plane, and you can cut the body in two more or less similar size, but in reality we are asymmetrical. If you ever take a picture of your face and draw a line, a midline, you will see how asymmetrical our face is, which is fine. This is how the universe created us. So we need a device that is capable of recording data with the asymmetrical patient. So our plane finder works this way. You tell the patient to come inside in a standing position, come inside the plane finder. They look into their face in that mirror that you see. Believe it or not, looking into somebody's eyes, yourself or horizon, would immediately put your head in a natural position. And that's where we can correctly register your plane, your upper occlusal plane. So you can see how the patient is placed inside the plane finder. We have to mark some anatomical landmarks on the patient's face. We use ala and tragus points, and we draw an imaginary line between ala and tragus. We call it ala tragus line, and that is more or less parallel to the occlusal plane of the patient, as you can see in this picture. This data can be transferred later into a digital or analog articulator. So this is a short video of the whole process that helps you get an understanding of how we use the face hunter in our workflow. So you can see the patient comes. The first protocol is that you make sure that the patient is sitting in a required distance to the face hunter. The patient, the technician takes 3 photos, 1 straight and then 2 on the 45-degree left and right. That gives us a full picture of the head, a 3-dimensional picture of the head of the patient. Then you can add some other photos with a smile, open a smile, close a smile, or any other smile picture that you require. Then you will use this fork. As you can see, this fork has some alignments, scanning surfaces. It's like a dummy that uses the babies. Inside of it, there is a fork, which is filled by impression material. And you put inside, you put that inside the patient's mouth. You let them bite slightly, and then you take another scan. Remember, then you can align the occlusal side of this fork with an intraoral scan of the patient of the upper arch. So the third part of it, as you could see, was a picture with the plane finder, which helps you align this data in a virtual or digital articulator correctly. Remember, our face or plane finder can be adjusted for two sides of the jaw individually. So there are cases that we have an occlusal plane of the patient on one side different to the other side. And our plane finder can be adjusted according to the patient's anatomical features. Now we bring the pictures inside or a scan software. We can define different landmarks, anatomical landmarks. And using other components, we have a plane analyzer as well. It's a device that the patient wears and it helps registering the movement of the lower jaw. So all of these tools can help a technician or a clinician to achieve better results at the end, because there is no and there's no doubt in how this information was gathered in the first place. If they are accurate, if they're reliable, if they are consistent and repeatable, that is something that we need to be careful, because I've seen cases that the technician or clinician gathered the data without confirming that this data can be repeated. So this is something that we need to be careful when you do a scan. Make sure that this scan is the right scan by just repeating it. Sometimes by doing the same process, you get completely different results. So it is an important point. Now back to our design, we got the face scan. We got the scan with the plane finder. And now using that data, we mounted our upper and lower and also C2 or pre-op scan, all in the same articulator, virtual articulator. Now, I'd like to show you different parts of our scans. As you can see here, you can cut the place of the mouth of the patient. That helps you set up a wax up, create a wax up, create different wax up with the patient's face and show it to the patient. Again, these are really important for prediction of what the patient will get at the end of this restoration. So we have everything. If you need inside our software or modular or modifier, you can realign your upper and lower arch inside the articulator if you need to. We define the upper scan as upper or main scan and the lower, and we define two C2s to help us design the denture. These are the current denture that the patient has. Now, in our tooth placement in modifier, in our denture design software, we have different teeth anatomy that you can use. We have Heroes collection for crown and bridge section that we've been using for years now. They're very popular anatomies. You've probably seen some of them in your career. They're very popular. We also created these days, just to help our dentures or production of our digital dentures, we also adopted this teeth anatomy for denture restoration, meaning that they are suitable for denture creation because they are bilaterally balanced. And also the cusp tips are not as prominent as our crown and bridge anatomy. So they're more shallow, they're more denture friendly. And also, as you can see, we have different denture teeth heroes braided to give that natural look and natural feel of a braided teeth of the denture. It makes the denture more comfortable for our patients. And these are some of our heroes collections. They all have Greek names, as you can see, Greek heroes. And these are the other advantage of using our teeth anatomy is that they can come with the root. And some of you designed a denture or a setup, when you have the root of the tooth, it helps a lot with your setup, because as soon as you put the teeth in a weird angle, the root will show you that this is not a natural position of the tooth. So it's very helpful to have a tooth anatomy with the root when you're doing the setup. I'll show you a little bit of the design that we're doing, so you can see how important it is to have the teeth anatomy with its root. So in this stage, I cut out the area inside the mouth. So now I can use this picture to create a couple of setups. I can immediately see their effect relative to the patient's face anatomy. I can have the patient next to me if I need to show them different anatomies and see which one they prefer, or your dentist. And now we decided for this teeth anatomy, at this point of the design, a little bit information about our modifier design software. Unlike many other software in the market, modifier is a software that's designed by dental technicians. So the way that it works is that you bring scan data, like all days that we used to sit on the bench. You do an ideal setup without thinking of what this setup is going to be at the end of the restoration. So you create an ideal setup based on patient's anatomy, based on their vertical dimension, all those landmarks. You create a few setup, then you can decide what you want to do with this setup. So you see how easily it gets. So you do the setup, then you can turn that to a digital denture. You can turn that to a setup or wax up, or you can turn that even to a bite splint. So this is the advantage that the modifier has versus other software. At this stage, like the design of any other removable restoration, and many other software also share this stage. You need to define the insertion direction of your denture. You need to block out if you need to. I usually don't block out my upper denture unless it's a critical case and I have to. Otherwise, because it's a soft tissue and we need to have this soft tissue undercut to help us with the fit. So after deciding for the insertion direction of my denture, then I easily can define the margin line or borders of my denture. So it's a very easy process. I start by clicking where I want to start my border. Again, after designing, milling, or printing, doesn't matter how you produce your dentures. When you design a few dentures with any software, whether it's Zirconzon software, or it's ExoCAD or 3Shape, my colleagues is going to show you another software, 3Shape, right after me, you will see the difference. They're all fantastic software. We encourage you, me and my colleagues, that you need to get into digital workflow as soon as you can. Practice, give yourself playtime. And you can see that when you design a few dentures, you know where the borders need to be, how much a spacer you need to use. These are little details of designs where it's related to your production method. So if you're printing, then what material you're using and what printer you're using, these things are very important. These settings are very important in order for you to get an ideal result at the end of your digital denture creation, whether you use a 3D printer or a milling machine. Now, our border is defined correctly. We can go next. A beauty of using teeth anatomy with the root is that festoning of your denture becomes a lot easier, as if you see the root underneath of your denture base. So that's another advantage of using teeth with the root, especially if you design a denture. Now, in this section, you can have different parts of your denture base parameters changed or adjusted. gingiva gap, if you need rest on some areas, if you need tissue relief on some areas, you need an extra spacer for some areas like a frenum. If you see a frenum that is so prominent and you think that the patient might suffer, you can add a spacer in this stage. And well, or upper and lower, you do the same thing, obviously, for the lower. After you finish your upper adjustment, at this stage, you can save these dentures either for 4 files, meaning that you can have 2 bases, STL files for 2 bases, and STL files for 2 set of teeth. You can also, if you want to use this as a try, you can merge the teeth and the base of the upper and teeth and the base of the lower and create 2 trying dentures, and you can mill them or print them with the material that you have in the lab or clinic, and try it in the mouth and see how patient reacts. If the phonetics are right, if the midlines are correct, if every anatomical features that you have in mind is actually correct in the mouth, then you can go ahead and do the final production with the more permanent material that we have in the market. Furthermore, now these days, we'll see a lot of requests and attention to digital denture conversion. Remember, now that the digital denture is part of the workflow that we see every day, it's also possible to change or convert your denture and somehow have a better fit and better comfort for your patient. If you're setting your denture or you're fitting your denture on a substructure, such as multi-unit abutment, direct connection, you can adopt your digital denture these days on a bar. Also, we have a technique we call double screw technique. So that's a very good way of creating a denture on a bar and screw it on a bar, which can be removed by a dentist. If you're concerned about the hygiene and you think that there's a chance that the patient will have some issues with cleaning the denture, you can use this technique. It helps the dentist to remove the denture whenever they want. You can also use a friction method that we have. In this way, you have the digital denture designed, then you design a sleeve, which we mill out of PEEK, and that will create our milling machines, by the way, they are super accurate. And I think I have a couple of videos to show you the friction that we can create with our milling machine. So you can design a denture, a sleeve of a PEEK, and a bar, and then the denture will use the friction, just the tightness of your fit, to be fitted on the bar. And the patient can also remove the denture if they need to. This is a denture that you see in is screwed directly on the multi-unit abutment. This is a gallery of some of the work that we've done in at Zirconzan facility for live patients. This is again a different a workflow by Zirconzan. This time we're using Modelier. And you're designing a bar as a substructure of your denture. You define screws on the bar. It's very easy to do it in our Modelier. We have screws, a virtual version of that screw that you can virtually put on the bar and create a hollow space for the thread, which will going to be milled by our threading tools in the production line. So we milled the base out of gingiva basic pink, the denture material. By the way, our denture, a new denture material will be approved hopefully by summer. We have teeth material approved already, or pink and gingiva. This will be approved hopefully by summer by Health Canada. So stay tuned for that. As you can see, the threading tool now is threading our bar for the secondary structure that is going to be screwed on the top of the bar. And as you can see here, we have 4 screws. And this is step, again, this is really good method, especially if you have all your implants in a weird angle due to not having enough bone, and the dentist decided that this is the best place that he can put or she can put the implant in. And you can correct this angulation using the double screw method that we offer at Zirkonzahn. And yeah, the material that we use, you could see there. Yep, that was another way or technique in producing a digital denture that is going to be fitted on a bar. We also have adaptation on the lock connector or connectors. We can help you if you're using different connectors. Please reach out. If you're a Zirkonzahn user, please reach out. We might have alternatives that are approved in Canada. We do have alternatives that are approved in Canada. Please let us know if you have questions regarding our locators. We will provide that information if you require. And on the production side, again, my colleagues, Kevin will talk deeply on the 3D printing, which in my opinion is going to be a major production way or method for many dental indications, including dentures. And I'll let Kevin elaborate on that topic. We at Zirkonzahn, we also have different milling machines. My favorite, the new machine that we released in IDS is M6, which will be approved and available in Canada, we're hoping in a year. The second machine that I like a lot is M2 telescoper. This machine allows you to mill different dimension of the disc from 95, which is the original Zirkonzahn dimension, to 98, which is the standard size these days, to 106 and 125 millimeter. The pink disc that you see in these pictures, they have 125 diameter, which allows putting 2 arches in one disc. This is really helpful when you want to have high volume production and you don't want to keep changing the disc. You can have one disc and you can put 2 at least lower bases fitted in that 125 millimeter disc. And yes, with Zirkonzahn components and workflow, you can achieve wonders. I've been myself, before joining Zirkonzahn, I've been always a big fan of their technology and philosophy. What they have is a philosophy. It puts the patient's health and well-being right on the top priority, and also technicians and clinicians' ease of using the equipment. Our equipments are optimum quality. I visit clients, sometimes they have our M5, which is one of the oldest machines that we have, for 11 years. And this machine still looks brand new. I told Mr. Steger, my boss, that you're not making it easy for us to sell more equipment because they don't need it. They're usually happy with the equipment that they have. It works, it's easily maintained and easily fixed, even by technicians that are not engineers. So this is another factor that Zirkonzahn keep advocating, is that our machines are made by dental technicians for dental technicians and clinicians. So they're easy to run, they're easy to maintain, and even easy to fix. So Ettore, my presentation is done. I can show a little bit of modifier software if we have time, or I can be ready for question and answer, whatever you prefer.
You do have a, thank you very much. You do have some time, Kevin, so please do show the additional stuff, right? Because I think it would be very interesting. Yes.
I'll be happy to. Let me see if I can bring my software here. And I'm gonna stop sharing and share again. There you go. All right. I hope that you can see my screen. Ettore, can you confirm that you can see the software now?
We can see it. We can see it. We're okay.
Okay, so guys, this is how our modifier software looks like. As you can see, it's very simple. And this is where you actually select the anatomy. And you can also change the way that the teeth are bridged together, meaning that if you feel that I like to have, sometimes personally, I prefer to have 3 sections when I'm milling or printing a digital denture. On the teeth side, I like to have my anterior as a bridge and 2 posteriors. It just gives me a lot more confidence when I'm cementing them or using glue or any other type of adhesive. It gives me a more confidence, gives me more time to make sure that each part of this bridge is fitted properly. So I can easily go through different anatomies. You can see we have Heroes collection and we have Heroes denture collection, and we also have different types of gingiva. So let's say that we want to use, let's say, demi denture teeth. I can go with the bilateral balanced teeth that are more suitable for denture. I can hit OK. Now in this section is where I can use different tools that the software provides to do an ideal setup. So I like to start by going to the precise and using the all features that allows me to move the whole arch simultaneously. So I can see the angulation of my arch. I can see the height and adjust it. I can see different angles, and I can see how my midline looks like. I can bring articulators if I need to. I can also go to articulation movement and create a dynamic adaptation for my denture teeth. I can also, if I need to, I can, let me remove the articulator. I can even change each tooth position individually. In this case, I can even use the mirrors option that I have. So I go single, I go using mirror. I feel that my laterals can go a bit higher. You can see as soon as I start moving my lateral on the left side, the lateral on the right also moves simultaneously. Again, to create a more or less symmetrical restoration, these options are really, really useful. On the collision options or adaptation options that I have is interdental adaptation, meaning that I can select that the tooth always remain connected on the mesial and distal contact points. I can ask the software to leave certain occlusal distance between the upper and lower, or just leave it as 0. This spectrum of colors help me as a designer to see how much space I have relative to my lower jaw. You can see that I can bring it in and I can see my contacts. If I need to, I can use my chain mode and start moving my setup. Remember, everything will move dynamically. So in terms of occlusal contacts and in terms of interdental contacts, you have full control when you're using our modifier software. Next thing, I can override. I have another setup. You can see that you can have multiple setups. Let's save this as a new one. We can define this restoration now as prosthesis or denture. And you can hit next. In this case, as you saw in my presentation, I can adjust the insertion direction of my denture. I usually use this kind of angle for designing of my denture, and I can hit from view, and the insertion direction changes dynamically. I can adjust some of the settings that I have here. Bottom offset is the space between integral part of your cavity part of your denture and the surface of the palate. The blockout angle is obvious, is the angle of blockout. We're not, again, using it for designing full denture. It's very important feature when you're designing your partial dentures. And you can adjust the tool diameter if you're planning to mill this denture. This is also very important. This is basically 20% bigger size of your smallest milling tool that you have in your system. All right, now you can hit apply and the software will start blocking out the undercut. That takes a couple of minutes. The blocking out takes a couple of minutes, and the software will operate a Boolean operation. It detects the undercut area and it will try to block it out if you ask the software to block out. In the meanwhile, while we're waiting for the software, again, there are multiple ways of producing a digital denture these days. The main fact is that we need to get into the race as soon as possible. We give ourselves enough time, playtime. I say playtime and people think that I'm not serious. I'm actually very sincere with my job as a tourist, that I'm very passionate about what I do and what I share. So we are sincerely want to advise you to get into designing of your digital dentures with any other software that you have. Whether it's Zirconzan software or 3Shape or ExoCAD, there are multiple software available. There's no excuse of not getting into the game, and give yourself enough time so you're comfortable with the technology. There is try and error. Still, it's like any other concept. You need to give yourself time to play and find out what is the best way of doing your digital denture. Yes, Ettore.
Kevin, we have a comment that came in, or actually a request, and it says, "Hi, Kevin. I was interested in that scanner that just can scan an impression and make a new model out of it. Do you have time to demonstrate it this time?" You do have some time because you got to finish by, let's say, Q2. So I leave it up to you. I don't know. Do you have time to demonstrate that for this?
Perhaps I didn't really. Do you mean the face hunter or an intraoral scanner that can scan the impression? I wasn't really clear on the question.
Okay, so let me read. Yeah, because it's not clear. Perhaps the individual DR Innovent can give us. He says, "Hey, Kevin, I was interested in that scanner that can just scan an impression and make a new model out of it. Do you have time to demonstrate this at this time?" So can you please clarify that?
Okay, I can explain. Maybe I can get to something that this audience wants to know. Many of intraoral scanners in the market, including our detection eye, are capable of scanning impressions these days. But one thing that you need to be careful with the concept. I see a lot of technicians just say, okay, I am going to, from now on, I'm going to scan all my impressions and I'm going to go all fully digital. Yes, it is possible. But one thing you need to be careful is that the light travels in direct or a straight line. So impression is a negative object. Sometimes you have deep cavities in that impression. You cannot expect any intraoral scanner, even the best one and the most expensive one, the Bentley of the scanners, is not capable of picking those cavities and undercut areas. So you still need to pour the impression and create a positive shape. A positive shape, like a model, is always easier to scan, whether you use a desktop scanner or an intraoral scanner. Impression scanning is possible. With first thing, the impression shouldn't be too shiny and reflective, so it doesn't reflect the light too much. That will affect the quality of your scan. The second thing is that it doesn't have much cavity, deep cavities. Then yes, or intraoral scanner. I don't have the scanner with me here, but again, if maybe we can talk with the tour and we can have another sessions where I can show our intraoral scanner. I hope that I answered the questions correctly, but please let me know if you meant something else or you want to know something else.
And we have some other comments over here. I think that the individual replied and said, yes, sure, this is close enough. So we dodged one bullet there, Kevin.
I hope I answered correctly. Again, Tori can put my email address at some point in the chat. And for you guys, if you need more data or more information about different things that I talked today, please reach out to me, and I'll be happy to answer.
Kevin, we have another comment from, let me do it, from Deepak. Okay.
Oh, okay.
Yes, he says, first of all, he likes the way you deliver. Okay, he says, boy, he takes his time and it makes it clear so everybody can follow it. If a recently registered newly graduate denturist wishes to acquire this equipment to be aligned with these modern day trends, what would be the financial implications and what are the options available to support this evolution? Also, if a more experienced denturist wishes to transition to learning about this technology, not having learned this during their formative years at denturism school, what hands-on learning opportunities are available to them from Zircon in Toronto, Canada? You think about answering this thing, and I want to comment on this thing because basically this is consistent to what I was saying in the opening introduction. You know what? Remember that now everybody, all the big president of the large companies in their media scrums at the IDS and Cologne, where we're mentioning that everybody's opening an academy to teach more how to make the clinic more efficient, okay, and how to learn how you can make your investment profitable. Okay, so I think that's what Deepak is getting to. So let's just see what Kaveh says about this. Kaveh, your turn.
Thank you, Deepak. Thank you for joining. You've been always a huge supporter of education at the college. Thank you. To answer your question, these days the technology is not as inaccessible or expensive as it was a few years back. A few years ago, not many people had a milling machine. Not many people even had a scanner. These days, the financial obstacle is not as big as it was a few years back. Many companies now, they have a financial ways of selling you the equipment that makes it easier for everyone to access this type of equipment. At Zircon, as I mentioned at the beginning of my talk, we have schools in Italy, which we are planning to expand and bring them into Canada as well, because we know the distance of traveling to Europe is not easy for all of us here in North America. So the plan is to have this educational centers in Canada by, yes, so it's going to be easier for everyone to access. We can have regular monthly, quarterly courses, hands-on courses. We're working with George Brown College on the educational side, hoping that we can send the first group of students or newly graduated students to our military school, open the door for them to see the cool part of the trade that they chose. Because we are sitting here and we could do any other job. We decided that this is what we want to do. we need to make it cool and fun as well. For me, doing digital dentistry is fun. It's a game. I can stay awake and play with the software all night. This is something I like. But we can also make it more joyful for newly graduated students that are worried that, okay, what's going to happen to my future of my work? Is it going to be here, or these huge multinational companies are going to take it away from me? It is your decision. If you improve your individual skills, individual talents, the way that you deal with your client, if your client is a dentist or if your client is a patient, you directly deal with the patient. What makes you in general different than the company that has no person? It's the company, you send a job, you receive the restoration, you don't talk to anyone. What makes you different to those companies are your individual experience with your client, whether it's a patient or a dentist. So improve that relationship, work on that relationship, improve your skills and knowledge, and make yourself stand out of the crowd. Staying in the crowd is good for those huge companies because they can gather and they can eat us up like a big fish eating all the small fish. But when we are together and when we stand out, we can fight back. We can keep our jobs. We can create a better experience for our patients and clients, and that improves our business as well. That's the simplest way to improve the business, having happy clients. It's simple, it's 7,000 years old, and it will work always and ever.
Thank you, Kevin. I still have some things. And first of all, I love your approach, Kevin, where you say that, give yourself playtime. I thought that was perfect. You know what I mean? And because to implement a paradigm shift, it's really difficult. And what happens if they don't implement this playing time, okay, where nobody sees you, okay, what's going on, then you feel psychologically, philosophically, you feel further and further behind, and it's more difficult to try to catch up.
Absolutely.
Okay, that is a difficult thing. Now, I think, with your philosophy, Kaveh, I think you fit the Zirconzon family very well, because I know Enrico, very well. And I know, when they talk about, Enrico is a genius. Guys, if you don't know him, the people that don't know him, he's a dental technician, but he's a genius. The guy is a crazy genius. Yes. And he always, when technicians tell him, I'm talking about dental technician, not dentures now, because Enrico is a master dental technician. When they used to tell him, oh, how can we make more money? He always says, you got to grow. You got to grow. Don't be like those technicians, that never take a course, and they say that they have a boutique lab when they've never taken a course with all the best guys in the world. They graduate and they just go to work day after day. They never improve. And then they say, well, what kind of lab do you have? I have a boutique lab. Oh, why? It's me and my wife. That doesn't make you a boutique lab because it's you and your wife. You need the education. So his philosophy, his educations, and like I said at the beginning, he's at the academy way before. And I know, he's done very well. He'll tell you how much money he makes and much money he spends. But his son, until a few years ago, I don't know if he still does it, he comes from school, he's got to play the piano, he's got to study Shakespeare. There's a philosophy of knowledge, of culture that he wants to bring in, and that was his academy, okay? So I love the fact that you say, hey, it's playtime. Hey, guys, go and play for an hour on the computer, and you will learn it. You will not be intimidated. Okay, let me see what else we have here. There's some other questions.
Please shoot. Yes. And while I'm working on this denture as I'm listening to you guys. So
yeah, okay. So it says that there's another question is, how well does your intraoral scanner scan a dentulous mouth? Okay, one comment. Good question. I'll let you be. I'll say something, guys. From my contacts worldwide, the best guy at this one, I'm gonna try to get him for you guys next year, is a doctor named Lucio Lorusso in Foggia, Italy, at the University of Foggia, and everybody goes crazy over this guy. I will try to get him for SDA next year, but you answer the question now, Kevin.
Very good questions. For fully edentulous patients, guys, we still require a semi-digital data acquisition, meaning because a denture is going to be fitted on mainly a soft tissue, not mainly, but partially on a soft tissue. Scanning a soft tissue that is moving and is not fixed is very, very difficult for an intraoral scanner. I can say impossible. The way that I like to use an intraoral scanner in a fully removable restorations is I use the intraoral scanner to get my primary scan, use that primary scan to make the custom tray. Remember, we are not cutting corners. We are using the tools because it gives us better accuracy, better control on the outcome. We're not cutting corners. One thing that people and technicians unfortunately come to me and ask, oh, so it's not faster. Why are you running? There's no race. The race is to create a job that doesn't come back. Your patient goes happy and you hope that you don't see him for a while or her for a while. The software, the digital equipment that we use only improves the accuracy and predictability of your outcome. Now, use the intraoral scanner, get your primary scan, design a really nice custom tray, print the custom tray, and then take the impression that you can scan and use it as your secondary or final impression. That's how I use the intraoral scanner for a fully edentulous patient.
Okay, so there's something else here. Oh, a comment from Amal Nawara. She says, it's really nice playing with the computer to design my prosthesis. My question is that, I guess what they're asking for is all the things kept all the time as a record for the future. They want to know if they can keep their playing time, they can save it and have it as a reference later on. Can that be done?
Absolutely, not within the software, but there are different tools that you can record your playtime. There are some free software. One of them is a recording software. I don't recall the name, but it's free. If you just Google has also a screen recorder tool. The free one can record up to 10 minutes, I believe. And if you pay a small amount of money, then you can record for hours and it's saved in your Google Drive. So very easy. As soon as you open your Google, you can use this software and start recording. It's a very good way, by the way, to see, let's say you want to start from beginning and then finish. You want to do it with minimum clicking. That video helps you achieve a better workflow, personal workflow. Each technician has his own way of doing things. We don't encourage you to follow blindly whoever and whatever that every other technician says. You need to find your own little style, your own signature in designing different restorations. Yes, there are some software available if you want to record your playtime.
Okay, so we have a couple of things more coming in, but one is I'm gonna ask about the last one of the questions at the end that I think is more important to finish it off. But there's one is just wanted to confirm. So for dentures, you are scanning the final impression?
Both ways. You can scan the final impression or you can pour it and scan the model if you don't have an intraoral scanner. Both ways possible. Even many of the desktop scanners these days, they are capable of scanning your impression and your model. It doesn't really matter. Some people prefer to pour the model because at the end you have the model to fit it, but some will do it directly on the impression. So it doesn't matter. Each way, each method is possible.
Okay. Kevin, another thing is this. Okay, you talked about milling and you talked about printing. And then I know that we're going to have Kevin Dillon talking about printing in the third hour of the presentation. Where do you see milling minimizing as printing increases in the next few years? Do you think milling is going to play a secondary role to printing?
Good question, Ettore. I can see the shift going towards the printing. For now, currently, these days, a milk product is more accurate than the printed. And Kevin, please go ahead. We had a lot of discussions with Kevin, so he can also elaborate in the topic on this topic as well. I believe the future of production is going towards 3D printing. Currently, what we have is the accuracy of milling machines are on the top and height of their accuracy. 3D printing are catching up. The material, as you mentioned correctly at the beginning of your talk, Ettore, they're improving. The fact that you don't waste as much material in the 3D printing method is also an advantage. We are going to the word that we're creating so much garbage in every industries that are not recyclable. So this is going to be a huge problem in the next few years. So 3D printing can help reducing amount of waste that we create in our own industry. Personally, I've done a little bit of research on how we can use a waste of our milling machines. I use the waste of our bite splints and denture grinding powders of a milling machine, and I planted a little flower just to see if it survived. It's actually at the back of my screen, right at the end of the screen. You can still see it. Yes, it survived. There are different ways that we should come up with, and we should start recycling the waste of our milling machine, as well as improving our material and technology on the 3D printing. But that's the shift that I see going towards the 3D printing.
Well, you know what? I think your presentation is being stimulating because there's a lot of questions coming in, and the interaction is great. I'm gonna go back to this one from Amal. It says, so the patient can get a new prosthesis. I think this is a yes or no question. So the patient can get a new prosthesis in case he lost, or if he wants to change the design?
Very easily. That is very easy. When you have all the digital data available, if they lose it, if they break it, you know, the production is now financially a lot easier and more accessible. And the digital data is very easy to preserve. So anytime you have a patient coming back with a little bit of modification, if they need to, or they lost and broke their denture, you can easily create another denture. That is possible. Yes, the answer is yes.
Okay, here we go. Pratik Arora asks, how about undercut on tissues in the mill dentures? How would you manage that? I think they're trying to stump you, Kevin. I think they're trying to stump you.
I love these questions because that was the biggest playground that I had on creation of digital dentures. In my previous roles, we created milling strategies. And our milling strategies right now at Zirkonzahn are capable of using this 5-axis technology of our milling machine and get access to the undercut area of your mainly upper part dentures. Yes, it all goes back to the capability of your machine. Obviously, many of our milling machines these days are 5-axis milling machines. That means that they can create a simultaneous, as I call it, a tango dance between the spindle and the place that you hold the disc together. And with the use of advanced milling strategies, remember, the machine is a blind and dumb equipment. It takes its order from your nesting or CAM software. So it's important that you have advanced milling strategies that is capable in your machines to go into that undercut area and make sure that all the undercut areas are milled properly.
Okay, I promise you, Kevin, 3 more questions, then I'll let you go, okay?
I can stay here all day. I can even join Kevin in the next one.
This one is from Vanit Kakar. Yes. Hi, Kevin, great presentation. Can we print titanium dentures or cast partials? How successful are those?
Yes, we can. 3D printers these days are actually capable of printing semi-precious or non-precious metal. There are some metal 3D printers available in Canada that are capable of printing from cobalt. Printing titanium is a lot harder because it's a very active element, titanium. Titanium and heat, titanium and laser they're not best friends. So yes, it is possible, but that 3D printer needs to be in a controlled environment, fully controlled environment with no oxygen, or you'll have a blast and a firework in that area. So printing titanium is much more difficult. Printing chrome cobalt is a lot easier, and the machines are getting more accessible and financially more desirable, because they become a lot cheaper than what they were $500,000 equipment that they were a few years back, and they were not that accurate. These days, yes, chrome cobalt printing is going to be a part of our digital workflow.
Okay, so a couple thing and a comment. How much is the whole system? Fernando wants to know. So how much is the whole system?
Which system? Are we talking about the metal 3D printer?
I think so.
If it's the metal 3D printing with so just the production side of it, you need a software to run that printer as well. You need the printer and you need the furnace for the post-processing. The whole system is around 150,000 Canadian, if I'm not mistaken. There are different prices, there are different printers. This is what I have in mind.
No, he says that, hang on, Kevin. He said the whole system for denture fabrication. How much? Denture fabrication, the whole
from
system.
Zirconzan.
Yes.
From Zirconzan, you need an intraoral scanner or desktop scanner. You will need modellier software. And if you go with the smaller machine, the cheapest machine, M1 that we have, your whole system will be around $60,000 to $70,000. You can use the telescoper machine, which will add about, I would say, 20%, 25% to the overall cost of your equipment. With the most expensive machine that we can give, which is M2 telescope here, I would say around 85,000.
You know, it's affordable. I mean, it's a business investment. Again,
absolutely.
I would recommend, and I'll talk about it later. I would recommend that you guys sit down. That's why you need those business courses, okay? And then you calculate your ROI. And
absolutely.
Don't believe me. Don't believe Cave. Don't believe this guy or that guy. You do
True.
your own thing. They'll put you in control. That would put you in control. And that's what this thing is all about. So anyways, let me finish with one comment from our friend Deepak, okay? He says, one of the most interactive webinars we've ever had at SDA. Great work, Cave and Ettore.
Thank you.
Exclamation. Anyways, Cave, I would like to thank you. I mean, it was fantastic, you know, like this thing. I'm glad that we had the time for the discussion, and you can see how everything that we talk about fits in. It dovetails on the academy, on the business knowledge, you know, on the investment for the future as to what's happening and what is not happening. So
absolutely.
I thank you very much. Very informative. I'm sure you and I will do more. I know you're working on a couple of articles for me, Cave. I look forward to reading them. And
absolutely.
You know, great presentation. Thank you very much.
Thank you, Ettore. Thank you, Bahar. Yes.
Cave, just before you go, I don't know if you look, but we broke the 101 attendees, which is excellent because a lot of the guys will come in later. Okay. So this is perfect. Thank you, Cave.
Thank you, guys. And thank you, everyone, for joining this webinar. Time for another espresso.
Yes. Okay.
All right, so, guys, have a wonderful day. Thank you, Ettore. Thank you, Bahar.
So now we go to Oleksandr Oborotov, and we have a new presentation. And I think one of the things that I would like to mention too, you know, about, you know, what's going on in the industry is, you know, because I see what's happening on the dentist side of things. Okay. Guess what? The dentists think that they can buy a printer and they can print. And then, you know, they buy the printer, they take it home, and guess what? They don't know how to design. And so now they're interested in courses from the design side of things, because, you know, like, if you don't know whatever, you know, software you need to know, it will not happen. So, you know, the next speaker, you know, like, I mean, we've done a course on another, you know, software, you know, but, you know, we're working on one with Oleksandr, who's very well known and recognized for courses on tree shape. So we're trying to help denturists, technicians, and also dentists on learning how to design. We have a course that is almost sold. I think we have a couple of spots left on ExoCAD there, and now we have a course with a few spots with Oleksandr that it's going to be happening soon. You need to invest in yourself, guys. And that's about, you need to invest in your knowledge so you can make informed decisions. What I meant is, where you guys need to be informed is the fact that you need to be in control of your future. Okay, you don't believe what I say, because I might be working them, and my job is to sell. Most of the people that I know in the industries are very honorable, but you need to make your own decision. What do you need for this one? Okay, and to achieve this and that, and we're gonna try to be here to help you with as much education as possible. Okay, but at the same time, you need to also control the education that you intake. So I'm gonna ask Oleg now to please come on in. Unmute yourself, Oleg. Sorry to wake you up, sir. Oleg, sorry to wake you up so early, but that's just the way it is. Okay,
no problems.
Thank you very much. We're doing a course with Oleg, and it's on April the 26th. Okay, it's a canine guidance splint. You should check it on our website, and it's the evening course. It's 6 to 9 p.m. There's a fee, but there's a valuable fee that is involved. I think it's $359 if I remember correctly. And so I encourage you to take the courses. Okay, it's a new paradigm shift. It's a new paradigm shift for everybody. And I suggest also to all you guys that at one point or another, you go to the IDS, which is like the Mecca. It's like the Mecca of dental education. And usually the things that you see in Germany, we used to see them in North America between 3 and 4 years later. Now this thing is condensed. Okay, it's there and it comes here. It's there and it comes here. So, but it's something that you need to do. So let me give you a little bit of background before I let Oleg take over. Oleg has a college degree in metal lathe. He's a metal lathe operator. He has 8+ years of experience with CAD/CAM in the dental field, and he worked for 3Shape and Argent Canada. In what role? I want you to tell me, what role did you have with 3Shape and Argent? But you can tell when you start the lecture, because I said to myself, I'm saying, yeah, what role? What did he do? Did he coach? Was he a coach with them? Did he assess problems that they had? And he's one thing about Oleg is he has successfully trained and helped Canadian denturists as well as dentists, implant surgeons, and dental technicians. Not only in Canada but all over the world, to transition their business to the digital dental domain. So we're lucky that he's doing this presentation for us. I'm gonna leave it now to you, Oleg, and I will listen. I will disappear, but I will listen very carefully, and we'll take it from there. Thanks, Oleg.
Okay, thank you very much, Ettore. Good morning, everybody. Yes, the question, what I did in 3Shape and then at Argent Canada. So I started in 2013 approximately. I worked for 3Shape. I did technical support for the dental lab department, and then basically over time, in a year, I was promoted to the supervisor of the dental department, because 3Shape has different departments to better support their end users and their resellers. And that's why they decided to create multiple departments, and one of those departments was the dental department. I was promoted to the supervisor of this department in a year, and then I started doing the supervisor job and dealing with difficult questions or some disputes from the end users. For example, something wasn't working or something, so I was involved in a lot of stuff that was happening at that time in 3Shape, and I enjoyed this. And at some point I decided I would not do only the dental department. I would like to do also the support of Trio scanner, of other software like ortho software. So just to kind of make my day a little bit versatile, because I'm not the person that likes just to do one thing day in and day out. It's a little bit difficult for me as I'm a creative person. So I did trainings for the internal employees as I was a supervisor, and obviously I did also trainings for new end users for 3Shape, or also new resellers at some point of time. So like I did the trainings, and I created training material and other multiple things in 3Shape. So when I was hired by Argon, I essentially continued doing the technical support stuff, because I don't know, coming overseas is not an easy task, right? And if you would like to do this, then you need to start from scratch again. And this is what I did. I started from scratch with Argon Canada. I started as a technical support once again. I did trainings as well for end users of Argon Canada on dental system, mainly all of the subjects of dental system, whatever was required, and Trios trainings as well. That's why many dentures know me as the person who trains on dentures, because I met a lot of dentures throughout my trainings in Canada. And this is what I've been doing myself on my own right now for almost a couple of years already. I decided to leave Argon Canada for my reasons, personal reasons. And I'm doing basically the same thing, just at a slightly different angle. If you look at this, for example, I do technical consultation as well. Like if you would like some mentorship in the designs, this is what I've been doing successfully. I have multiple customers at this time as well, and everybody is happy, and they keep coming because I'm focused on quality and not just to get the job done. This is how I try to do everything.
I gotta
Quality in
promote you
everything.
more, Oleg. I gotta promote you more because there's a huge need for this. Go on. Sorry for interrupting. Go ahead.
No problem. So I was finishing with this stuff. If somebody is interested more, then they can contact me. You can reach out to Ettore, and he's going to provide you with my contacts, or if you know me personally, or if you know my contacts, so you can find me on Facebook, that's fine as well. So yeah, let's get back to the presentation. Today we're doing an upper and lower dentures, and I'm going to share my screen. I would like to start from scratch once again. I would like you to see everything, how it starts. I don't want you just to see the design part only. I think it's important to see where it all starts and what you get to deal with at the beginning, because watching design is one part, but creating something from scratch is another part. So I'm going to share my screen. So many things right now with this. So many options with this Zoom. Previously, it was just share one screen and then switch between the screens. Right now, like they ask you multiple questions, host only, participate, share with participants. What kind of screen are you going to share? Okay, you should see right now my screen with the main interface of the dental manager.
We're just seeing your desktop with a demo. It just says demo.
Yeah, exactly. That's the main interface of the dental manager.
Oleg. Yeah.
So I started already one design, but I'm going to do exactly the same thing for you, and just not to waste time on, again, starting the design module and all that stuff. We'll go gradually into the design. So this is the main interface of the dental manager, and the most important side you would be looking at is the left side, where you see all of the filters. You can filter your cases. Basically, you can look at this as an Excel sheet where you can filter also different items, and your basically your Excel sheet would be somewhere in the middle, because where you can see the case number, for example, creation date, delivery, who is the customer, and all that stuff. You can also add extra columns in, let's say, your Excel sheet, so-called Excel sheet, where you can also find out what the volume of the denture would be, like if you would like to do the, like if you would like to know this information, what's the shipping date, if you filled in the shipping date and all that stuff, manufacturer, and so on and so forth, as you can see right now in that screen. So the 3Shape Dental Manager is a really highly customizable software, and depending how you work, you can also adapt the software to your workflow. It's not like vice versa, because I believe in the idea that the software must help you in the implementation of your conventional, like work. That's why it's not vice versa. You don't have to, the only way you probably will adapt is just the way the software is set up and the interface in general. So then on the left-hand side, like I mentioned, this would be the filters. And then at the top, you will see some auxiliary like auxiliary links and some auxiliary buttons, which we do not touch at this point. And then at the bottom, you will also have the preview of the case. Basically, it should give you that preview of the scans imported, also some summary of the information that you also can see in the main window in that line that says creation date and everything. So basically the same thing, just to sum up, and then the indication type, the material you use for this design, and then any comments if there are any. I don't have any comments. So let's start the case. Usually I like to start the case with the right click because it's much easier. Again, trying to save some clicks. If you save a few clicks every day, then I think at the end of the day, if your job is mainly designing, it would be a huge amount of clicks, and you put less strain on your wrist, because it's very important. And this is the part of your body that's gonna work a lot throughout the day if you're designing. So right click, new. And here's the order form. On the left-hand side of the order form, you will see some basic information. You may type in like the name of the patient, last name, first name of the patient, which if you customize, again, you may have the software reflect the last and the first name of your patient to the order number. This is what you can see at the top right now, in the middle. For example, if I write anything else right here, then you will see it again reflects the patient's name. I think it's very important, because if you do use this feature, then obviously you will know somebody by the name and not just by the numbers, because numbers do not tell you anything, but the name of the patient is something that you would like to see. And if you customize it this way, it's going to be easier to manage your cases and going through the day of your work. So then this would be the patient's name. Then you can leave some comments, which would be reflected there on the left-hand side, and then at the bottom of the main interface, if you remember that. And then to start a denture, an immediate denture or just a regular denture, you would need to select one tooth on one side. It's going to be tooth number 7 on one side, because we did not use number 8. And then if you go over to the other side, you may just hold the shift key and then left click at the same time. And then you will select all of the teeth between the number 7s. It's very important because it again saves you some time. If you did not do this, then you may obviously as well click each tooth and then select the same number of teeth if you wish. But I think it's more dynamic if you're doing this just on one side selection and then going over to the other side and then shift and left click. Once you selected all of the teeth on the upper and lower, the best would be to start with the gingiva indication. So if I click on the gingiva indication, you will see multiple options for the design of the upper and lower denture for partials or anything denture related at this point. You are going to use the first option, in this gingiva design, then it shows you the name of the material and the type of the manufacturing of your denture, which is very important. So the material, you can select different materials, color, whatever works for you. But the most important part in this section here is the manufacturing type, or shortened type. You may have different types, but basically they are broken down between three main types here. It's the monoblock type, it's the base with designed teeth, and there are two more basic ones, which you can see. I actually got rid of one of them because it's redundant in general. It doesn't help at all. Base with artificial teeth manual reduction, and there was another one, base with artificial teeth milled reduction, which I deleted because it doesn't work. I believe this is something that has to do with the Chem5 output for Ivoclar. Base with artificial teeth, the only way I would use this for carded teeth design, if I really wanted to send somebody design who is going to insert carded teeth, but that's the only thing. The monoblock would be creating just a train, then milling and printing. There are two parts which differentiate only in the base, denture base thickness, because for the Luciton material, for the print, the base should be thicker, according to Dentsply Sirona recommendations and their technical sheet. And the milling again and print, there will be another huge difference. It's the drill compensation. If you would like to use the drill compensation for your milled parts, that's fine. But what I see more and more and get feedback from more and more denturists, not only from Canada, but also from the United States, that the fit is better if you don't use the drill compensation, even if you are milling this denture. Because if you are doing drill compensation, then some parts of the undercuts will be flattened to some degree. That's why the fit changes and it's not that precise anymore. You may try this yourself, or if you know something about this, you've tried this by yourself, you have some experience, then please share this with everybody here. It's a huge audience. So for myself today, I'm gonna select print, and then there's another selection which could, again, define some of your manufacturing special like preferences would be whether it's going to be print or mill. It's a little bit confusing in my system because we have just selected print in the type, and then we have to select once again mill or print. So basically I differentiate for myself between the manufacturing types like milling and printing, and then the manufacturing process for this is a separate thing, because if I selected just the type here in the upper this drop down menu, then it's just the parameters for the denture, finishing, and manufacturing at the bottom would be also related to the teeth manufacturing. So I'm gonna select again print. And then the next step you would like to do, since we're designing teeth, it's going to be a tooth selection. So at the top on the right hand side, you will see anatomy. I just click anatomy and it jumps automatically to the very last option, which is artificial tooth option. And I did this in this sequence for a reason, gingiva and then anatomy. You could have done this vice versa again, like you could have started with anatomy and then you would go back to down to the gingiva. But if you do this vice versa, you start with the anatomy, then in this case, you would need to again do another click, because usually when you start your anatomy, then dental system thinks you would like to design a crown, not a denture. That's why you would have to go to the right-hand side of this drop-down menu of the anatomy and then do this one more click to select artificial tooth type. And then since we're doing this digital dentures, most of the, I should say, denture libraries in 3Shape dental system software, they do not allow you separate individual teeth output, and that's again for a reason. There is an idea behind this, because everybody who has everybody denture libraries, manufacturers, which you can see in the dental system software, the carded teeth manufacturers, basically they just digitize their teeth, then obviously they still would like to continue their business selling their carded teeth. And what they just give you here is the convenience, I guess, of having their teeth in the design software. So something which you're familiar with, like that special familiar anatomy and stuff like this. But we can touch on this a little bit later. And then the other main part would be object type. In the upper right corner of the order form, you can see model. And then if I click the drop down, then you can see two more options, this which would be digital impression, and then the other one would be just the regular conventional impression. If you are working with intraoral scanners, and if you scanned with your intraoral scanner an impression, a conventional impression or wash impression, whatever this may be, then you would need to select digital impression because it's all digitized, right? If you're scanning your regular impression and you have a desktop scanner of 3Shape, let's say, then you would need to select impression only. In this case, I have already models and I have started the design, if you remember. And at this point, if you had a scanner, then you wanted to scan something, then at the bottom on the right-hand side, you would like to click scan button or OK, and it's going to create another case here, which then would be or should be populated with the scans. So if you right click, then you would need to import the scans. But since I have done this already, let's just go over to the design part. And I'm going to share my next screen with you. I hope everybody can see this screen now. It's the design screen. If you could give me your feedback, what you see. Do you see still the design, or do you see the interface of the dental manager or the design?
Oleg, I'm going to ask this question now because I guess it's relevant at this point. Amal asks, which one is the most accurate of the models?
Which one is the most accurate? In my opinion, the most accurate would be, again, I think for the suction dentures, it would be a wash impression. Like if you take that, sorry, not wash impression, but a functional impression. If you take a functional impression and then you are going to scan this with your scanner, whatever the scanner may be, a desktop scanner of different, like different brand, or it's going to be an intraoral scanner. You may use both of them, but I think this is the source of the material, or like the source of the scan that would be more precise and better fit in denture, in my opinion. And this is what I have seen. And everybody obviously have heard of suction dentures and all that stuff. But everything else, if we're not talking about the desktop scanner in general, then I would say that working with an iOS scanner or intraoral scanner is a challenge at the beginning if you haven't done this before. And if you're just starting, then I would not recommend like going digitally completely from day one. I would still, as I don't know if somebody else maybe give you the same type of recommendation, but I would ask you to take your impressions the conventional way and then also try to scan the patient one at a time with the digital scanner so that you gain some experience with this, because it's not easy, especially with the dentulous patients, like as if we're talking about crown reconstruction or like something which is abutment based, then it's a different story. It's a little bit easier on the scanner, but if we're dealing with an edentulous patient, especially the lower jaw, where there's a lot of moving soft tissue, then it's getting even more complicated than that. If you never tried that, then if you try it, then you will see what I'm, you will understand what I'm talking about, because I tried this myself as well during the trainings, and it's not an easy task. I was also watching some people that I trained, and it's really intimidating at the beginning. So I'm going to start with the design. If there's no more questions, then I hope you can see the design part at this point I'm sharing. And just
Oleg, there is another question from Deepak. It says, what is your opinion about flex time scannable impression material from Culture? since no powders or sprays are needed prior to scanning. Are you familiar with that?
No, I'm not familiar with Culzer. This is what I heard. The only thing that I know from Culzer, I worked as a reseller when I was at TrueShape. I was working with the Culzer as a reseller. And in the software, in the dental system software, I tried their library, but some of their nice libraries, they are payable. And that's why I don't know a lot about Culzer. Sorry.
Okay.
But
that's no problem.
yeah, in general, if you ask me about powder, whether you need to use powder for your intraoral scanner or desktop scanner, in general, all of the scanners, if they are color scanners, then basically the spectrum of the light is a second time, like somebody mentions here, the spectrum of the light, because the previous speaker was also mentioning the spectrum of the light. So the white light is can be split into different rays of light, and for the scanner, your color scanner or intraoral scanner or desktop scanner, it sees just three colors, or may differentiate just three colors. It's red, green, and blue. That's why they call them RGB as well. And the calibration of the scanner happens within the scheme RGB. So what happens is that if there is a really saturated color, which would be either red, green, or blue, that's why the scanner may omit this part, because in blue room, in blue light, you will not see anything. Like it should be, you know, like it's going to be just the blue color. So basically, this is why the scanner does not see that. Or like if it's a 100% green color or saturated color, that's why the scanner will not see this because it's green. There is no difference. And the same, so basically for the dentures, the same happens with the denture base. Like if you are scanning an old denture, let's say of a patient, or if you have your red wax and you're trying to scan this because you created a wax stream, right? And most of the times the wax stream would be in pink color or red color. So if you're having that color, you may have some issues with the scanning, and that's probably the only part that I can address at this point, because I have seen this multiple times with the denturists that when they're trying to scan their wax stream, the wax stream is not scanned well, even in TrueShape scanners where they hugely promote that no powder is required and stuff like this. But even in the desktop scanners, they will not capture some portion of the wax stream just because that wax stream is a pink or red color, which is really saturated and sometimes also reflects light, which is another thing which that is a hurdle for the scanner to scan the area because of too much light reflection. That's so much I can tell you at this point, probably. And I hope I was able to answer your question, or at least to give you a slight idea about this. No more questions?
You can go on. Yeah.
Okay, so the design. Here's the design. And on the left-hand side, the design of the design module, you can see back and next buttons. And then at the just a little bit below, you will see the name of the step here. And then the overview, what you're doing. We're doing upper and lower dentures. And then the sub-step names. After the sub-steps, you will see the current instruments for the current sub-step. So basically occlusal plane on the left-hand side is my current step, and the instruments I have to accomplish this task would be the following, what you can see at the bottom on the left-hand side. The right-hand side has some sliders for visibility, you know, like the upper jaw, lower jaw. You can use hotkeys here in the software. There are a lot of hotkeys, and if you would like to get really dynamic with the design, then you would need to memorize them. I encourage you to look into the technical documentation that every dental system has. If you hit F1, if you download this documentation, of course, you can download this for free from the dental system settings, which is not the main. I'm not going to show it to you right now, just to save some time. But if you ask your seller, they would be happy to help you with this, definitely. And then we have some icons as well, but most of these icons on the right-hand side, it's called the icons panel. Most of these icons, they are helpful in the design of crowns or something which is not related to the dentures. So it's a couple of icons that I use sometimes for the denture design. That's all. So in the main theme at the top, you will see the workflow bar. The workflow bar shows you the current step, which is highlighted right now in a little bit lighter grayish than usually. I call usually 3Shape 50 shades of gray because everything is gray, but it's really nice to see it. So basically, if we're starting here at this point, the software would like us to define the occlusal plane. If you would like to create your post stem and you haven't carved out your post stem on a stone model, or you didn't have it in general, then you may go one step back, because this step with the scissors at the top, you can see that icon is the second icon from left to right. This step is by default skipped, and usually it's not needed unless you would like to clean up something on the scan, or you would like to create your post stem. I have created this post stem before, but if you wanted to create yours, for example, then usually I would come here with the settings like 140 millimeters for the radius of the tool, and then you would start doing little by little, carve out your design of the post stem the way you like it. Yeah, so it depends on the preferences, right? It's a custom design, so up to you what you would like to do. But it's one great way of creating your post stem, because if you're going to do this on the denture intaglio further in the design, it may give you a little bit hard time, because you don't see actually the anatomy of the patient, and that's why I prefer this way of creating post-palatal seal, because it makes it easier to see where and plan this in general. So use this, it's a very helpful tool here. Then occlusal plane basically is very important, and you would need to set this. You may set this with multiple options here, 3 options on the left-hand side again, if you look at into the instruments, but the most simple one would be 3 points, and this is what I'm going to do. K9, and then the second point is always the midline, and then another K9, and here's the plane. You may want to adjust this if you wish. Why you would want to adjust this plane, the more you adjust, the more precise you are with this plane, the better the proposal of the teeth will be, because this software, the design software, relies on this occlusal plane to give you the tooth setup proposal. If you don't care about this, and if you would like to set this up, slightly, later at the smile composer step, then that's fine as well. But the better you do this here, the faster you would be in the future at the smile composer step. What's more, this plane is used by the virtual articulator if you know how to use this here, or if you would like to use it here, if you prefer using it here, then that's another good reason why you would need to set up this plane the way it should be. Otherwise, do whatever you can do here. Then the characteristic points would be the points we would usually set for the analysis of the model. You may use the slider on the right-hand side just to preview the upper model and set those characteristic points, which you can see on the left-hand side as well. We have tuberosity number 1, depends which tuberosity for you is going to be number 1. Then incisal papilla is the second one, then tuberosity number 2, and then 2 K9 points at the top. And then again, it depends which K9 is going to be K9-1 and K9-2. So there is no difference. There is no hard rule about this in the software. Then for the lower jaw, we have retromolar pad center, then buccal side, lingual side, and then midline, central ridge point. Then on the other side, again, retromolar pad, buccal, lingual side, and then 2 K9 points. What are we doing here? We are trying to build here an ideal arch, right? based on the landmarks, or you may, like if you're doing these landmarks properly here, then you may rely on these landmarks in the future. If this is something that you do with the designs of your dentures, like that curve here of the arch and all this stuff. I'll show you these lines in the future because I think it's better to visualize what I'm trying to say at this point. Just memorize what we're, remember that we set these landmarks and I'm going to return to them. So then next step would be upper jaw boundary. Once it's there, you have two options. The second option doesn't work in this workflow. So just the very left icon would be the green icon. You click that icon with the left mouse click and you start outlining your denture base. You could skip this step altogether and continue going forward, but you would need to create at least something, some simple selection, like let's say like a circle, and then continue. If you don't want to create your gingiva at this point, that the software will require you to do at least something to continue, because unlike in ExoCAD, the 3Shape software for the dentures design, it's like it has a strict structure, and one step precedes the other step. So basically, you cannot jump forward. Like you could with ExoCAD, like if you're using that expert mode of ExoCAD, it's slightly different, unfortunately, but there are some things as well that make sense why it's like that, because the software expects some information prior to moving to the next step. Now, the same is going to be for the lower jaw. I'm going to create quickly that outline. Basically the same thing which you would do for the upper jaw. It's slightly different in that slightly different anatomy, right? A little bit different. And I'll design this slightly faster at this point, just to get going with the design. This is the most boring part here, in my opinion. We can adjust this later. So like, again, I'm not paying attention at this point with this selection, because I know that I can usually adjust this later. Or if you would like to do it here, then you can do it also more dynamically than just moving points, because points is not that effective in my opinion. So once you finished your spline, there's a hidden menu. If you right click the white line here, then you can select fast edit line, and then all the points disappear and you can draw. It's a nice feature. I like this feature. Usually when I close my spline, then I use this feature to finish and refine the outline of the denture base. But we're moving on, and we'll deal with this later if we need to. I think it's not really important because it's a live patient, but it's been finished for a while ago. I just decided to take this design because it has some spiciness to it. There's a little crossbite if somebody already recognized that. If not, then there's a slight crossbite. I thought just doing the dentures, upper and the lower would be too boring, and I decided we could create a crossbite on one side here. So then the blocking out step. So we moved on to the next stage, and we're looking at the overview, and the overview shows us in gray arrows on the gray background that we're dealing with the upper jaw. And the blockout step, then the instruments for the blockout step, what you can see is the preview. At the bottom, you can see the preview of the models from different angles. If you don't like to rotate the models back and forth. You can set up your previews at the bottom, and every time when you switch change your insertion direction, which is in the main video here, in the main scene here, shows you that blue insertion direction. If you would like to move this insertion direction, then on the left-hand side, you will see those arrows and also the degree of the movement of one step and in whatever direction you take. If you do it, then it's going to change. But for the dentures design, it's irrelevant to change something here. So usually go with the selection, what the software thinks would be the best. Usually the software is trying to analyze the insertion direction based on the base bottom, so the bottom of the model, but maybe slightly different as well. Different suggestions, but most of the times the software is good at defining the software for the insertion direction for the dentures. Now, wax trimming step. If you blocked out something, then you probably want to work on this. I do not block out anything unless it's an immediate denture to have some space for the tissue conditioner. Then I would block out some of the undercuts at the front and some of the extraction areas. But at this point, I'm not touching anything. And we're moving on to the lower jaw. The lower jaw is the same. We're not touching anything and moving on. The only part probably I would like to block out right now at the wax trimming step would be in the third quadrant right here, because to me it seems like it's sticking out a little bit. So I don't want to sculpt this on the integrity of the denture, so I will just block it out slightly. And we're moving on again. At this stage, unfortunately, I lost my PDF file with the dentures with the denture libraries in dental system that I had in the previous presentation. But basically, again, I mentioned when we were looking at the order form of the dental manager, then for the dentures, then I had mentioned that we would need to connect our teeth into a bridge, because not all of the manufacturers, or I can just count them on my fingers of one of my hands, like how many manufacturers of digital denture teeth allow you separate individual teeth output. Basically, if you have an iVotion library, this would be your one option. The rest of them, I think also Dentsply Sirona, but I'm not sure, probably not. At this point, unfortunately, I don't remember exactly, but I should say some of the free libraries, if I show you the preview of the libraries, you can see right now at the bottom, there is a preview of the Candular library. It's a free library and it's the standard library. If you haven't downloaded any library in your dental system software, then this is going to be the first library that comes by default. And this library does not allow any individual teeth. They want to sell you this teeth. Vita, they do not allow this, obviously, for the same reason. Some different libraries like Culzer as well. Fabulous Smile is the free library, and this allows individual teeth, but the anatomy of this library is a little bit cranky because, as you can see, or if you know the Fabulous Smiles and the creator of Fabulous Smiles from Europe, he decided to scan live patients and then create libraries out of their teeth. So, like, for example, if I'm going to click the preview of this, if I can, yeah. If I click the preview of this library, so basically what you see in those photos, you will have to deal with this because you will see some used teeth, some, like crowding and all that stuff, used occlusion and different stuff, which makes the smile a little bit eccentric, I should say. So this is how it is. For example, with this Fabulous Smile library preview, I tried to, for example, let's see if we have something special here on the occlusion. So basically what I like about this library is that you will see a lot of nice and natural anatomy, but at the top, you can see at the interiors, they are set up like that original patient had. And it's a little bit questionable whether somebody would like that front smile with the setup like this. So, but it's free and it's individual tooth setup output also free, and you can do whatever you want with that library. Nobilium, Nobilident, if you can see that at the bottom again from the drop-down menu of the digital smile libraries, you will see Nobilium, Nobilident is also a free library. You may use them for any of your designs. The only trouble with that, I don't like their, for me, for example, I don't like their anatomy, and it seems to me to be really too much artificial. Then Calzer, libraries that are payable, Vertex Dental free libraries. You can also use individual teeth, but again, the anatomy is not that nice. Phonaires, obviously great library, great looking library, but more lingualized setup, and I don't like using them a lot. Or in general, Ivoclar's library, in my opinion, the best library would be iVotion library, because it has like all of their best looking, I guess, libraries. And what's important in that library is that the teeth are extended longer because of that special manufacturing Cam5 they have for this bicolor discs, and it requires like longer tooth because who knows where your, where it's going to end up. And usually their teeth, just the regular Phonaires and SR Vivodent libraries, they have shorter teeth, like something that you can see in the preview at this point right now. But if we go, and then some Densplicer on the teeth, Masad libraries, they are all, Masad is like semi-free library. You would need to have this activated as well on your dongle, if I'm not mistaken. Then some of the Densplicer on the teeth as well. And the iVotion library, the library that I like. And then once you select iVotion, you need to also select that check mark just a little bit below that says show full arch libraries. Once you click that, then all of these libraries is going to be available here. And then you can select the library type you would like. For example, at this point, I would like B71 because this is something that is very close to the wax up. And you can see some measurements of the library. You can see the height of the library and stuff like this. At this point, what we have is the preview of the Ivoclar library with the bicolor disc imitation, which you can see iVotion part, right? Those lines around the teeth necks, but I'm going to use the sliders on the right-hand side to get rid of them. At this point, we're going to quickly set up the teeth and then move on. I think the other part is more important. So just basically quick setup here on this side. You can use the tools on the left-hand side. There are different tools you may use for this design, including some hidden menus. 3Shape obviously like some hidden menus in the design, so it would be like a nice discovery for yourselves. And then, so the first one in the design tools on the left-hand side is the occlusal plane adjustment. Basically, this is what I was doing just right now. You just move the teeth, all of the teeth available in where you want them, left, right, and you can also increase the size of the teeth. And this is probably the best part about digital teeth, because you don't have to care about the design. Basically, you can use one library, and that library will be good enough for everything. Anyway, Ivoclar has different types of one and the same library, which is like in real life, right? And then the next option would be arch setup. Arch setup allows you to work just with the arch transformation. So basically, it's going to flex your arch, and you can adjust that arch to whatever you would like to do with your setup. Like if you would like to increase, make the arch a little bit wider. Second option and third options, they are basically the same. It's the same manual setup. The only difference is that the second option, which I'm using right now, it adjusts the contacts between the teeth automatically. Like if I pull my teeth slightly to the back, then they are going to jump automatically to find the closest contact. And with the third option, it doesn't do that stuff. So basically you have more freedom of what you would like to do with these teeth. Maybe you just move them for a reason slightly into the back. But it's with the second tool, it's my preference only for individual designs, because if you're doing like we are doing upper and lower, then usually when the teeth jump, to find that closer contact, then it screws up the lower jaw all the time. So I don't use this a lot for the upper and lower cases, unless I'm, mostly for the upper, because the lower is usually screwed up by the second option. So I don't recommend using that. And then the individual, the number 4 would be the individual transformation. The individual transformation obviously is just for the individual tooth. You can move individual tooth, you can grow the tooth, you can do multiple things with this. And there is a hidden menu. If you right click this tooth on the individual setup, you can also try to bring this to the mesial contact, the distal contact, and also to the antagonist. You can also remove this tooth and lock the upper teeth. This is what this is the feature that they realized in the 22nd version of the software, which is highly recommended for those who would like to do the or who designs the class 3, class 2 bites or cross bites. It's a very useful feature. It was so difficult in the 21st version of the software to set up any irregular bite class. So right now it's a huge help, and I'm going to show you obviously how it works, because we're working with one cross bite on one side. So this is how the teeth are positioned, and then I'm going to remove the upper jaw. You can see right now, I mentioned that I'm going to go back to the landmarks. As you can see right now, that green outline of the arch is your ideal arch. And if you look at the back of the model, you will also see the retromolar pads and the tuberosities. If you define them properly, this will give you the opportunity or the option of defining whether there is a cross bite or not. Obviously, like the tuberosity is slightly in, and on one side it can be designed as a proper occlusion, but on the other side, in the third quadrant, there is definitely a cross bite. So that cross bite, this is something that we're going to work on today. So just to set up everything in the correct position, I can also remove the upper jaw by using the slider, and then I will go back to the number 3 option from left to right on the left-hand side, and I will grab by the left-click the last molar, second molar, and I will adjust the
Oleg,
arch.
sorry for interrupting. We have a question from Amal.
Yeah, sure.
Is there an option that the software will select the best location of the teeth according to the ridge resorption, for example?
No. It's all, like the preference of the user, and there is no such option which defines that. If it would be possible, then you would spend more time on doing something which probably is not necessary for yourself. Let's say like the software would require your input on where, like some of the landmarks are. I know we've set up some of the landmarks, but those are not really relevant to the setup. And then it would require some extra information from yourself as a user. And if it's some kind of information, then again, it's some learning curve and some input from your side. If it's some input from your side, then it's maybe a time waster for you if you're not doing this all the time, or it may be an arbitrary step. And if you're looking this as an arbitrary step, then probably, but I think it involves a lot more on the development side. That's why it's not probably something that they realized. Not probably, but they didn't have this option at this point, but may have in the future if they have enough requests, because this is how the business model of the software development works. You ask for something if you're a key opinion leader, or if you, you're asking for something which would be useful for a huge number of people, then this is what is going to be implemented into the software, because they would like everybody, to be happy with the software for the most part, right? So the more people they can get to be interested in the software and use this function, this is how they are looking at this. It's a business, right? So I did some mistake here. So I started adjusting this side of the lower jaw just according to the arch. But the problem with this is that I did not lock the upper jaw, and that means all of my changes that I did here, for example, if I hide the upper jaw, and if I go back to the third option, and if I change my setup of the posteriors, if I again go back to the upper jaw, then you can see the posteriors of the upper, they also have moved, and this is what I don't want. That's why what I want to do is that I will go back to the initial setup on this side, and then I will turn on the upper, and I will right click this upper and use lock upper teeth. This is the best that they could have come up with at this point, in my opinion. I like it very much. So now, sorry, the upper teeth, they are not moving, but the lower teeth, they are completely mobile at this point. So then I can adjust this once again without any changes to the upper jaw teeth. We'll slightly adjust everything. We have some space, and what's important here is that all of these teeth, they are positioned for the guarded tooth setup, and if you're working with these teeth, then you may, if you're using this bring to mesial contact, probably, like in our case, we're designing a bridge, then you could probably care less about this mesial and distal contacts. But if you're working with the guarded tooth, then it's a good idea to bring this to mesial or distal so that the tooth keeps the contact distance. And usually the distance by default is 0.2 millimeters between the teeth to create nice contact. And if you would like to make sure that you are doing the right thing with this contact adjustments, I did this by mistake, then you can use one of the sliders, which is here on the right-hand side. Is the bottom slider, which looks like the bullseye. If you turn that on, it will show you the check marks, and those check marks will mean that the contact between the teeth is optimal. If you're having some troubles with this, with some of the teeth, then you will see something like this information mark, and then it's going to show you that tiny letter what kind of trouble you're having here. Like, for example, it says here A means antagonist, so there is some collision with the antagonist. Now, what we're doing, I'm going to unlock the upper jaw right now, and I will continue with our setup. But to continue with the setup, we need to adjust the contacts right now on this side of the crossbite. So what I'm going to do, I would like to visualize the hard contacts. Then I'm going to use the second option in the sliders on the right-hand side from bottom to top. That's the one that's going to give you the contacts and also the scale on the right-hand side of the contacts. And then I will start with the upper jaw. Everywhere where you can see right now, the blue color, that color is the hard contact. So I would like to change some of the setup here for the crossbite. And then we're going to move on to the lower jaw. There will be some adaptation of the teeth design in the later stages, at the later stages of the design. But at this point, I just would like to bring this to some common denominator or something which would
me again.
Yeah.
With a question. I did not understand why you prefer to lock one jaw when you move the opposing teeth. I think he's looking for a rationale as to why you did that.
Yeah, so the only way you would do this in a regular, or like not the, like not the class 1 bite, because what you're trying to do if I was like, let me go back, for example. If I didn't lock the jaw, once again, probably you missed that part. If I didn't lock the upper jaw, then all of the posteriors that I moved slightly away for the, like from the uppers, that's what created that irregular bite at this point. The upper teeth, they would move with the lowers, and this is what I didn't want. I want them to stay where they are because I just wanted to move the portion of the, like just the end, free end of this posterior teeth. And if I'm doing this, let's say, with both arches active, then I will move these teeth at the same time, and which I don't need because I would like to have just the upper where it is, because here's on this side, there is a crossbite, right? So if I wanted to, let's say again, if I look the lower teeth and if I go to the upper jaw, then we could even move it right here because this would be appropriate. And then if you're looking back, then you get the crossbite. And if I did not lock the lower jaw at this point, then I would move both of the teeth in the same direction into the mouth, right? So what's the point of all of this? Then I would need to use, so the difference between the 22nd version of the software and the 21st version of the software bit is that now I can lock one arch and use the arch transformation just to move all of the teeth in at once on one arch. Before, I had to use the manual transformation for one individual tooth and adjust the crossbite, or like if it was a class 3, let's say, setup, then I would do this, individually. I would move the uppers, I would position the uppers, and then I would start taking out the lowers, just to, and grow them, because you need to grow them in size for class 3. And this is where this lock arch feature helps you a lot, because you can lock one arch in this size of tooth, and then for the, let's say, class 3 setup, you could have grown the lower teeth slightly bigger to the extent that you would like, and all that stuff. So I hope it explains everything, and let me know if it's still not clear, or we can also break it down during the course on the dentures design. Yeah, and also I wanted to point out that you can see right now the teeth are longer than they usually would be in any of that library or in the preview libraries. Usually the teeth end somewhere slightly below, like 2 millimeters below the green lines around the teeth. So those are basically margin lines. But here, yeah, it's a little bit longer. And this is what I like, because you will see also later. Obviously, I cannot show you everything, but you will have to probably only trust me or believe me that this is true. But I'll show you some other things and why the longer teeth are better. I mean, below the green lines, below the margin lines. Okay, so let's continue at this point. That's fine. Maxillary base. That's the only trouble with this teeth. So basically it says tooth intersects the gingival outline, and it shows you which teeth intersect the gingival outline. So basically the software doesn't like that the pink is higher than the teeth here. So if you would like to get rid of this trouble, just shrink the tooth to the point where you don't, it doesn't cross the pink. Here, that's fine. And here is fine. If you don't do this, then the software will not let you go at the next step. Maxillary base, you will have to do this. And at the maxillary step base, there is no way to adjust the teeth anymore. So the only way you could pass that step is to adjust the outline of the denture base, and then later again to sculpt this 26 one more. I don't say right there. Now it says gingiva lines violation, and it says that these teeth, 17, 16, whatever, so the green line, what you can see right now, is closer than 2 millimeters, and that's that would be very important for the teeth, which would be carded. But since we're doing a design type of teeth, then we could care less about this. It's just redundant stuff because. Excuse me. So our teeth, they will be cut to the gingiva or to the soft tissue automatically. So we don't care about this anymore. What we have here is the denture base adaptation step. And you can see again the outlines around the margin lines of the teeth. And that's that evotion part that I like here, because at this point you can lower those teeth, that gingiva part, and it's going to change the size of the tooth. If this is something that you could use, then definitely use this design. I sometimes use this if I need to lower the gingiva, or pull the gingiva higher, I should say, or lower. Sorry, I need to drink some water. Yeah. So this is the iVotion thing, actually, and you will not see this with any other library, but it's a huge and useful feature, in my opinion, if you would like to customize your design, your pre-design of denture base better. And then there are different types of gingiva aesthetics, as you can see here on the left-hand side. You may also customize yours. This is mine, which is customized, and here you may see the customization settings. Edge profile is one thing that I have not set up yet, but I would like to adjust this more to all the way to the left-hand side, because I would like more rounded edge shape than that one of a, I don't know how to say this, whatever, triangular shape, right? So usually if you have this in the middle, which is slightly more like that angled shape, or more to the right-hand side, then you would have to sculpt your gingiva all the time. But if you adjust this edge profile to the nice and rounded shape, this is where you will get this more precise every time. So again, in the long run, it speeds up your design in general. If you are working, you're earning your living with the design. If you just do this once in a while, or a couple of cases, probably it's not as one thing that you would like to customize here. And since I created a printed denture, I selected that on the order form. Then at the bottom of this section, you will see drill compensation, and the drill compensation is off. If I wanted this drill compensation, then I would set this to on, and drill radius would be adjusted. At this point, drill radius is 0.1, which is not true, but usually, and by default in the software, it's 0.65 millimeters, and it works well. So I'm going to uncheck the drill compensation and move on with this. The same would be for the lower jaw. I don't think we have time to adjust the lower jaw outline, and then we're going to move on with this, with the selection that I made before. It takes some time to calculate this, but it's getting there. There's a lot of calculation going on right now at the background. It's trying to fill in all of the space between the points and between the teeth, and it tries to snap the gingiva portion to the teeth. So this one, I'm going to go with the selection what we have right now. It's less relevant to adjust this right now. We're not making this perfect. But sometimes if you have some really weird anatomy, or you have some parts which like go down, maybe like an extraction site or something, or like there's some space where you're doing partials and in between the teeth there is a little space, then your settings of the base thickness at this point, it shows 3 millimeters here on the left hand side. Sometimes it may fail on you saying that the gingiva has narrow part. And that narrow part basically somewhere in between the teeth if there is a little space. So you would need to decrease the thickness number and then sculpt it yourself. So basically wax it in real life, if we call it real life, then conventional way, right? So right now we have connectors. I have preset connectors with the 70 facial scale, lingual scale 70, and center scale is 60. This is basically the minimum you can go with. And I usually like this because if you make it thicker, or by the standard, I think it's 95 for facial scale, or 80 for facial scale, lingual scale 95, and 80 something would be the center scale. I think it's too thick because if you look at the dentures in between the teeth, then you will have a thicker bridge. Obviously, if it's a thicker bridge, then it's going to be more obvious that this is not a natural tooth. And if somebody cares about this, then I think then it's something that you should consider and play with the parameters to see which of the thicknesses work for you, and then preset this as default in the settings of the dental system software. So now sculpt an anatomy, I could sculpt something, or I could have cut the teeth to the lower jaw, because as you remember, we had some hard contacts on this side at least, but I'm not going to do this because I would like to remove this contacts from the lower jaw, some extra material. So I'll leave this upper jaw untouched with the sculpt on anatomy, and I'm moving to the denture base step. In the denture base step, we have some tools here like tweezers, for example. With tweezers, if you prefer working with tweezers, it's one way of moving the tissue without some huge changes to the tissue, because I'm just pulling this higher, but I do not change the landscape of the tissue in general. But let's say in comparison to this tool, which is the smoothing tool, I just smooth that and it changes the anatomy of the soft tissue. You can see the red parts as well. Those red parts is the minimum thickness that I preset to 1.5 millimeters, if I'm not mistaken. Yes, 1.5 millimeters. If you're designing printed dentures, then I highly recommend to preset this again in the settings of the software. In the artificial teeth part, you may preset this, and this would be a huge, again, time saver for yourselves. Because when you calculate your printed denture, then obviously the base should be thicker, again, according to the, let's say, Dentsply-Sirona Lucitone material, because everybody works with Lucitone, probably, right? It's a more robust material than something that you can find on the market as well. So so for example, 1.5 will save you some time with doing some adjustment of the denture base to the teeth, because if the denture base is too thin, then you will have all kinds of errors at the end, that the gingival part has some holes and stuff like this. So it just starts with holes and then moves on and on. You may have some holes in the teeth as well, but that's mostly for the partials designs. So here, just a simple design. We can even grow here, like if I this section and close this section more, let's say like this. I don't care a lot about whether I'm going to go more into the scan area. I will not, because the morphing of the gingiva at this point and sculpt of the gingiva is protected, or was protected at some point, and you cannot change the intaglio. I used that little checkbox on the left-hand side in the sculpt settings that says allow sculpting on inner surface. That means I can change the intaglio. I can show you. So basically, you have to be very careful with this if you're working and your checkbox allow sculpting on inner surface is on, because you may change everything. And like once we are done with the design here of the upper portion, let's say we're done with this design. It's not something important at this step. Everybody can do this, right? But what I wanted to point out here is the post stem, right? So at this point, you may just want to smooth your post stem slightly if you wish to do this again, just to create a nicer look, a more sleek design. Then if you just smooth it slightly, then you get a nice post-stem, in my opinion, better than you would start sculpting it here. At some point, I would do this all the time. I would sculpt only here, but then I realized that it has more, like I mentioned, landmarks you can rely on to create that nice and nice fit and post-stem as well. Because sometimes if I would do this at this step on the intake layer of the denture, then it would not be that precise. And then what you can do here as well, like once we've finished our design, then you can also add a name tag, also some extra features as well there that we're not going to touch. There is no way to create that artificial rugour to simulate the natural one for the patient. But if you are taking your time and you would like to spend some time on this, you could sculpt. If you're good at sculpting with the wax knife tools here, you could do this by yourself with a little practice. So then this step is a coupling mechanism. So basically here, the teeth will be adapted to the gingiva, considering the scan as well. So if I remove the gingiva part at this point, you will see some blue lines around the teeth just below the margin line. So basically this would be the insertion direction of our bridge. And if you are designing and if you see, like we see this right here, these blue lines coming out of the gingiva, then it's not a good sign. And I recommend you tuck this in or go back and add a little bit of wax on this design so that these blue lines, they do not appear on the outside, because it's going to screw all of the denture socket here. I mean, teeth sockets. It's not going to be nice. And you would have to redo this, but better be proactive and do something about this before you will have some troubles at the end. And what's the most painful part in this, when you overlook this and then you realize before manufacturing that there's some, some problem with the denture base, and you would have to redesign, which would steal 20 minutes or 15 minutes of your time just running through this and probably playing with settings, maybe more. So the final part for the upper jaw, we will have to do the same for the lower jaw. So pre-manufacturing step, here is where it defines the minimum thickness under teeth. For the printed denture, again, according to the Dentsply recommendations, it would be 1 millimeter of denture base thickness, because Lucitone does not print well at 0.8 millimeters of denture base thickness, which is the basic and default setting here in the Dental Manager for milled dentures and for printed. And glue space would be 0.14, again, if you're working with the Lucitone material and their glue. And then at this point, I'm going to click next, and the software is going to calculate all of the stuff. Again, it takes a little bit of time. If we don't get any errors, then we're lucky and we're going to move on to the next step. If we get some errors, then we'll have to address them, but I don't think there will be any errors. Usually the errors may, again, come up somewhere where you have limited space, like let's say you are doing a partial, like I mentioned, and you have some, tight space between the teeth, and you squeezed in that little tooth. But what's important to know and remember that this software usually likes to wrap around the gingiva, wrap around the tooth. And if you don't have that minimum thickness of the gingiva around the tooth, this is where all the troubles come out. And this is where, like, obviously the software is trying to communicate to you with errors, and those are not really intelligible. It's, most of the times, everybody is, confused by the errors, even me sometimes. It shows you some weird stuff with different weird numbers of teeth, which is not true. Like it can show you like tooth number 36 on the upper jaw, which was the last time during the presentation. So it was a little bit awkward. But if you know how to get around those errors and you know what the software is trying to convey to you, what message, then you will definitely move on. At this point, I would like to focus on this part where we had that crossbite, and the best probably thing for dentures is to cut contacts without cutting the contacts manually, right? So this is where it's going to be automatically. And pay attention at the teeth. The teeth have been reduced, and we're moving on to the denture-based step. At this point, I should have started the virtual articulator, and I would adapt the contacts a little bit, but I didn't do this because I don't like how it works, or in the 21st version of the software, it taught me actually that it's not a good idea to start this on the anatomy, sculpt on anatomy step, because it works weird and sometimes it may error out. Maybe it was just in the 21st version of the software. I just don't use this anymore at that at that step, because sometimes you may also get the gingiva generated too high, and it may get, especially with partials, it may get in the way with the teeth, and I just would like to see where everything cuts. So at this point, since we set our plane properly beforehand at the beginning, then this plane for the virtual articulator is more or less what we want, but I would like to move this plane slightly in. I don't know whether it makes any difference or not, but I've seen one report of one person. They did some, I don't know, they did some studies for themselves, I guess, like just to prove their point, like when this plane of occlusion for the virtual articulator was shifted to the side, or like somewhere, to the front or to the back, then they found out that it does not adapt well the contacts of the crowns. But it was just for the crowns. I don't know if it was the same. They didn't test it definitely for the dentures. I don't remember the company who did this, but I just was a viewer of that webinar. And I don't know whether it's true or not, but I don't have any option at this point to probably play around with this and prove my point, though I would like to do this. I didn't have any time, unfortunately, for this. So I'm trying to do everything, let's say, like by the book, or closer to the book, so that everything works. And so far, I didn't have any troubles. Usually, once we do our excursive movements, then you will see there is some more contact, obviously, on the crossbite side. But I would like to adapt the designs to 30 microns more. And if I click the adapt designs, then again, it removes 30 microns more out of this. Why it's important and why it's a good idea to do this here, because if you do this precise cut of the anatomy, let's say to another anatomy, to the upper jaw, or whatever your jaw may be, or natural dentition, then that precise cut may lock the occlusion, and it will be more difficult for the patient, I guess, to move the jaw, and it would lock in more. Usually when you adapt the designs, at least by 30 microns, then you open the contacts, and even though it's still a nice contact, 30 microns is not that much, but you still get proper open occlusion that is going to slide back and forth properly. I'm not going to touch the gingiva part at this point. I guess we're running out of time, so I'm just going to use the coupling mechanism. And while we are going to do any of these calculations, I would like to answer your questions, not to waste our time, because it's going to take a while, as well, as you may have noticed already.
Yeah,
So
there are a few questions, Oleg, and I will read them to you because you are running out of time. And the first one is, how accurate is the Trio scanner or the desktop scanner with this software?
Like I mentioned, the accuracy of the Trio scanner or any intraoral scanner is going to depend on your personal prowess at scanning, in my opinion, because you may create a lot of double scan and all that stuff, but what they promote in Trios 5, at least 3Shape, they have this intellectual scanning strategy where even if you make that scan like double layered, because sometimes if you abruptly go in, let's say, from one side and then abruptly change to the other side of the jaw, then it may double the scans, and then try to connect this both parts somewhere in the middle. Then this is how you create layered scans, and those layered scans are usually something that I can see with the beginners, with the dentures who want to start digital, but they don't have still enough experience to scan edentulous patients, or like with the dentition, at least for let's say for partials as well, because they still are not sure how to do this properly. And this is what I can see. Like, I still get this customers with the other intraoral scanners, let's say like Prime Scan, iTero, and so on and so forth, and they still get this double layered scans. I don't know if these companies have some technology for eliminating these layered scans or double scans, but in Trios 5, what they have is like, even if you're like inexperienced user and you make some mistakes during the scanning part, which would usually end up or result in doubled scan or layered scan, then Trios software makes it good for you. Basically, it stitches the scan properly. I'm not sure how accurate it is, but according again to the studies that TreeShape conducts, or somebody else like external labs or clinics or whatever, like whoever decides to do this study, they have shown that Trios is one of the most precise, or if not the most precise scanner on the market at this point. It doesn't mean that you have to buy this at this point. I'm not promoting this, but I feel like this is, again, the most easiest and the most usable scanner on the market at this point, because I know the price is probably higher than any other scanner to start, but the user experience and the learning curve of this scanner will be faster and better, in my opinion, just again because of the user experience. And since you are in the software and you have to deal with this, then your user experience is something that matters a lot. You need to think yourself whether you would like to invest into this in the long run or not. But again, with coming back again to your question, because I was digressing, I think intraoral scan, again, it depends on your expertise, how you scan, and when you are going to become really skilled at this. But in my opinion, Trio scans are really precise. I cannot tell for any other scanners, but so far I have multiple, I don't know how many throughout all of these 2 years. I've had a lot of I have done a lot of designs on different iTero scanners and all of that stuff, and I have not had any troubles with the precision of the denture. In my, at least nobody returned to me and said, hey, something is wrong. Obviously, bite adjustment is something that happens all the time for the dentures, but not something special that was in terms of the like the surface imprecision, because even doing immediate dentures where you think like you're removing some part of the skin, then you think you may remove more, you may like leave more and all that stuff. It still evens out, and it's still like, if you know what you're doing, obviously, when removing the teeth and how you would remove the teeth, again, something that comes with experience. But if you know how to do this, then I don't think there's going to be a lot of discrepancy in the intraoral scan. What comes to the desktop, as to the desktop scanners, I think it's more precise because that model is usually static, and it will more depend on how you took the impression and then poured up that model and all that other stuff, and whether that impression is still fresh or maybe it's shrunken already and stuff like this. But usually everybody is doing their best to pour up models as soon as they get these impressions, right?
Okay,
So,
there's another one that I'll blend in. It's a comment really and a question. And the first one, the comment indicates, I noticed that the system is designed to do steps not in order. I mean, as we do in the patient's mouth. And then Deepak adds, is there any manual user guide to learn the sequencing steps required for fabrication? So it's really the same thing of dentures using TreeShape. If there is one, could you please type or send the link in the chat? Thank you. So they're looking for a step-by-step approach which they're familiar with, because the steps that they've done with the other way, they don't follow the order that they used to.
Yeah, I may understand this, but this is how the software was created. And believe me, this software was not like created by the developer who just decided, okay, now we're doing this step because I just want this way. Usually this approach is really complex, and there are multiple key opinion leaders who work on the software. And the way you can see the overall outlook of the denture module design in 3Shape software is probably a huge contribution of Ivoclar. And in cooperation with them, I think this is the fruit of the cooperation of 3Shape and Ivoclar. As to the workflow, if you would like to get the workflow or familiarize yourself better with the workflow, how it works in this software, then I recommend, again, cannot recommend enough, is that if you are a 3Shape user, then you can go into the control panel of this software, and you could download the technical documentation. It's a special part of the manual that deals or like explains you all of the workflows available in the 3Shape software. Let's say crown, starting with a crown, simple crown, and all of this other stuff, including bite adjustment for the dentures. And I hugely recommend, this is the part that is massively overlooked by all of the users. They think they will learn this, just by, doing like as if it was a digital, like it was a game. Well, to some extent it's a game, right? But you would like to be productive and start, from scratch and going as if you were an expert already, let's say of 5 years. But what happens, everybody is overlooking this technical documentation, which gives you every step. And like, if you are patient enough, then you can take this technical documentation, study this, and you would be not worse than some of those people you can find on 3Shape study group, like when they, have some answers to your questions and all that stuff on the workflow, because this is actually where it all starts. And I really recommend this. I don't have this like in some kind of concise version at this point, but if you would like to, I can see if I can export this in a PDF format. I'm not sure if it's possible, but because this manual is a huge manual, and it's an HTML, I think, format, which is a lot of stuff because there are also videos embedded and all that stuff. So I think that manual takes approximately 500 megabytes. If again, this is something that you would like from me, then I can make it happen through Palmieri Media Group. I'm going to prepare this on my side, just this part. If you would like, if you don't have this software and you cannot get this information by any other means as a 3Shape user, then I will happily export this manual and give it to you. It's not a big deal for me. Sure.
Okay, you know what? We're gonna take you up on that. Let's see what they say, anything, Oleg, because they will get back to me. But really, again, really, really informative education that is delivered. Again, I would like to remind everybody that we're having a course, and we're gonna keep on doing this courses Oleg throughout the year. We're gonna pick dates. And the message that I get from Tabe and Oleg is that you got to learn to play and just dedicate some time to get familiar to what it is and just enjoy it. So it's a mindset, that it's a new learning, it's a new paradigm, and you got to invest the time. And I guess if you go with an approach that, it's like fun and it's a game, then you will learn. Again, the course for Oleg, it's for April the 26th. It's in the evening. It's Canine Guide and Splint. Please register. We'll keep on promoting it, and we'll give you the stuff. I'm gonna ask Oleg, depending on what you guys say, to create, what he suggested that he could do for us, and then you guys would have, something that you can refer to. Oleg, I don't know how to thank you. You're a great guy. It's a dry subject, but you make it fun. And, it is good. And I think that everybody will benefit if they take your course, and it's necessary. It's a necessity now. So I thank you. And
You're
I
welcome.
look forward to having you as a guest speaker again. So let's go. Ciao for now, huh? And
Bye.
we'll go now to Kevin Dillon. Kevin Dillon. Hey, Kev. You notice that Kevin, people are used to it. Usually when they say, well, like you've done very well over the years, but I'm not a dental guy, But really my biggest success is the ability to network and bring the best people, like whoever they are, because it's easy to access. It's not easy for other people, but after 28 years, I'm always, it's easy for me to access the talent nowadays. But I still remember before I introduce you, how much I admired your father, I was in dental and then I'm not going to repeat it, but there was a discussion between the technician and he was sitting back just listening. And then he made a comment and I said, how smart this man is, how wise he is, It was about the future, okay, about the future and outsourcing and so on and so forth. I said, man, this guy, and I really enjoy it. But now I enjoy having you on the program and thank you for stepping in. You got about an hour or, a little bit more. And Kevin is going to talk to us about the question. Actually, I'm going to start you with a question because
Okay.
Cave said, well, Kevin Dillon would probably speak to this, but let me just give him a little bit of background and then I'll start you with a question. Then you can run with it. Okay. So
Okay.
guys, Kevin is the dental channel manager of Canada and Mid-Atlantic and Northeast US for Envision Tech. Yes. Okay.
Yes, I'm the national sales manager for Desktop Health. I cover
Yes,
Canada.
that's what I
and-
thought. And I said, how did this get in here? Okay. He's got over 30 years in the dental field. He started with Leach and Dillon in 1990. He finished his time there as a president and CEO, and he sold his company to American Dental Supplies. He's a great lecturer, both nationally and internationally, and he helps dental labs, in their strategic growth, which is what I said, like what's happening now. Some people have been doing this all along, the academies, Henry Schein is creating an academy, Ivoclar, so they teach you, like what to do. These guys have been doing it all along. He left dentistry in 2012 to pursue a career in 3D printing, working in the industrial sector and marketing, strategy 3D printers. And then he came back in 2015 and he's a subject matter expert in 3D printing dental applications. Thank you very much, Kev, for being here. My question I wanted to start you with, I came back from the IDS and I was a little confused. Again, I'm not a dental guy. I try to read what's going on. Yeah. Is milling going to decrease in interest among the thing while printing increases as we move on? Like, is printing gonna be more powerful in the marketplace than milling? Is milling gonna retreat? That's a question.
Yes, and Kaveh was correct. I am going to speak upon that, and it's going to be the first part of my topic. And I think, in all honesty, it really comes down to material development, and then once the materials get to the point where they can replace everything that's being milled, then that's where we'll see the replacement. Because there are efficiencies in 3D printing that don't exist in milling, that, as everybody knows. So, in my opinion, it's all about material development.
Okay, so then you start your lecture. I'm gonna disappear, but listen to you. And then, oh, Kev, do you want me to interrupt you when the questions come up, or we leave them at the end?
No, you can interrupt me when the questions come up. I'll try to look for the chats to see if they come
Okay.
up, and it's just gonna be fluid. If you want it to be more discussionary, that's fine.
Yeah, it's up to them. Okay.
Okay.
Okay, it's all yours, buddy. Thank you.
All right. Well, Tori, thank you so much for inviting me. It's a pleasure to be on. You always have the best programs, my friend. You always have the absolute best programs, and we've known each other quite a long time. So thank you so much for allowing me on here on this platform to speak to everybody. As Tori said, I've been in this industry. My father brought me into the industry back when I was a young kid. My uncle was a denture technician. My cousin was a denture technician. My father was a maxillofacial technician before running Ivoclar, and I've been doing this for 33 years. I tried leaving this industry actually in 2012. I had sold Leach and Dillon and on board there for a few years and realized that digital dentistry was where it needed to go, and where I was particularly sitting, I wasn't moving into digital dentistry. So I gave up dentistry altogether and I started selling 3D Stratasys printers in the industrial space. Everything from medical to prototyping to manufacturing, and 3 years experience in 3D printing before going back into dental. Envision Tech found me in 2015, and then I started back into dental with the 3D printing. So I've got 33 years experience in dental and 10 years experience in 3D printing. And so it's been a fun ride so far, and it's a very exciting time to be in dentistry. I am really finding this to be, probably out of all the years that I've been doing this, this is the most exciting time. Things are moving fast and we're seeing some pretty amazing stuff happening. Let me share my screen here.
Like I said, we only bring the best, Kev, so that's it.
Well, thanks.
Okay, the screen is okay, Kevin.
All right, we're good. All right. So again, my name is Kevin Dillon. I've been with Envision Tech since 2015. I'm the sales director basically for North America and for the company. And we had some changes over the last few years, which I'll go into. But Desktop Health, our commitment is to advancing 3D printing, but not only in dental care, but also in advance my slide. Hold on. There we go. But we're also advancing 3D printing and material development for other aspects of human body replacement. Right now, we're a big player in the hearing aid 3D printing, and we used our bioplotter to create to regenerate your tympanic membrane from your own DNA. So we're doing some pretty crazy stuff and really kind of get into orthotics. We're involved in some skin grafts stuff now, but we're more involved in the whole healthcare solution in 3D printing. To what Ettore had asked me, why are we 3D printing? What's the benefit of 3D printing? Is this just a fad? Is everybody going to go back to milling? Is this just something that's going to come and go? I don't think I would have changed my entire career leaving dentistry if I didn't believe 3D printing had a future in manufacturing. And from our perspective, one of the questions that I always get from dental technicians, or statements, shall I say, is printing's not there yet. It's probably the most cliched statement that I hear almost on a regular basis. And I can see from the perspective of where I hear that, I certainly understand. But when we take a look at some of the data, when we compare milling to printing, just from the technology standpoint, Japan's Tokyo University found that 3D printing can be more effective by means of producing dental crowns. We're looking at offset and unoffset tolerance scans here. And when you look at the milling, there are imperfections in the milling. In the 3D printing, we have a much clearer tolerance scan and more green. So our 3D printing restorations are showing a higher accuracy. And when you look at why this is happening, it's pretty obvious, right? I mean, we have access restrictions, right? 4 or 5 axis mills. We have tool requirements, and they don't always get into the accuracy areas that we want them to be. And so when you shine a light into it, one layer at a time, we can capture unlimited geometries. There is no geometry that we cannot print. And so the ability to advance 3D printing from an inexpensive printer to something that is really looking and measuring in terms of 45 microns on the X and Y, and that's an extremely tight tolerance. When we look at what is the clinical this is a study showing the clinical acceptance for 3D printing versus milling. And we're showing a significant larger number of subjects reported feeling greater comfort with 3D printed splits. With a scale of 0 to 100, and 0 representing excellent comfort, the mean for 3D printed was 15, and the mean for conventionally manufactured splits was 42. So, when you look at the night guards, for example, this is something that we're looking at materials. Key-Splint Soft is the #1 material for night guards. Why is that? Because when it goes into the mouth, it softens a little and becomes more comfortable. So the accuracy of that, if it fits more comfortably and is softer, you're going to have something that's more intimate fit. A traditional impression with a model and a suck down, you have multiple variables, and your variables, and they're not going to translate into accuracy. And so you have this hard soft splint to take advantage of the inaccuracies of that fit. So 3D printed splints are extremely accurate. And as we start to see milling versus printing, we are increasingly the number of scanners that are on chair side and printers that are in labs. So in the study done in July of 22, 53% of clinicians in the United States have a chair side intraoral scanner, and 61% of the laboratories have 3D printing. And I probably say that 61% in the United States is probably pretty low. I would probably say close to 80%, at least some form of 3D printing. So if you look back on 2018, that was the year that really advanced a lot of the 3D printing. And then again in 20, when we had COVID, a lot more got involved into intraoral scanning because of what we were going through at the time. And so that digital movement and the digital journey that we're on is moving faster than it ever has. When we look at 3D printing, we have to ask ourselves, what is the most important factors of this technology? And when, according to the LMT survey, the #1 factor that all respondents had was accuracy. If it's not accurate, it's not worth getting into their practice to lab. Speed has now become more and more a factor in 3D printing, because we're seeing a lot of chair side printing, especially on like the All-on-X hybrid provisionals, where you're doing same day surgery type cases, or you're trying to get a splint the same day where you can print it in 35 minutes. Reliability, which is uptime on that printer and not downtime, and your cost per print, right? Efficiencies and cost. We start with the technologies. Now, desktop health was actually EnvisionTech, which was founded in 2002. EnvisionTech invented DLP printing. So we're the company that created the digital light projection using a projector to cast an image into a vat of photopolymers, was where we started. And we started with wax in the dental laboratory space. The dental laboratories have been printing since 2007. This is not new to laboratories. But it's important that as a company, that it's our mission to make industrial grade printing. This is production level, high accuracy, speed, accessible and dependable for all clinicians and laboratories, and that we want to advance dentistry through this technology. We were purchased. EnvisionTech was purchased by Desktop Metal, which is a publicly traded company, which has 20 different printing platforms, and their main focus is on binder jet technology. 183 million represents our revenue in Q2 of last year, and we have 163% growth year over year from 20 to 2021. So it's a substantial company that represents 60 countries around the world. We have a platform of many printers and binder jet, metal technologies, titanium, polymers, all the way to sand casting, 3D printing technologies. So we're not just a printer that's made in China, that's manufactured to print some dental technologies. We manufacture our printers here. The technology is born here. And we are looking at a total solution on not only generating printers, But I believe materials and applications are really the driver of where we're going in that dental space. With Desktop Metal or Envision Tech, we have over 260 patent pendings, 1,400 published papers. We've got 190 plus materials in our catalog. 34% of our employees are engineers or scientists. We're really in the development of this. And 30% of our profits from that we make go back into R&D. So we're really a technology-driven company, and a lot of this stuff is organically grown within what we're doing. I believe education is key. We're building a team of what we call dental application engineers, experts in the fields of dentures, especially all-on-X conversions, where we're going to start to provide education, not only in form of webinars, but hands-on programs. We're going to be offering our first hands-on program at our tech center in Peoria, where we're going to take our workflow for dentures from start to finish. So if anybody's interested in something like that, we're starting those types of courses. I think all of this kind of starts with the technology, where we began and where we moved. Envision Tech has always been known for making a very highly advanced, really complicated pieces of equipment that, you know, robust, but it takes a little bit to know. We've taken under Desktop Health, made it a more simpler, more efficient, more easier technology through our Einstein printer.
The photon, the most basic particle of light. With wave-like properties as proved by Einstein, photons are all around us. In everything, the foundation of all life. From photosynthesis to human sight, it's the fuel that powers the natural world. But the photon powers something else. It's at the heart of our 3D printing technology. We've harnessed the power of light to bring you Einstein. Our industrial strength projector generates a highly efficient 385 nanometer wavelength that's as close as you can get to natural light. With a state-of-the-art lens perfected over decades of tireless research and development, NanoFit 385 allows for exceptionally precise curing, printing applications with stunning clarity, perfect fit, and a finish that looks astonishingly natural. And now, through Hyperprint, we harness the power of heat and closed-loop processes to deliver applications in minutes, not hours. We're shining a spotlight on the photon in a striking new way. The basis of all life in a world that will never be the same. Introducing Einstein, the perfect fit.
So the Einstein printer is an advancement of what we've been doing for 20 years. It's a lot of what we've kind of accumulated through allowing us to use things like Hyperprint, which is utilizing a closed loop process, where I'll explain a little bit, and heat, to have using a light source of 385. 385 wavelength, and you might see this in a lot of other 3D printing specs, is a wavelength that is being emitted by the projector. And some either use 385, some 405, some 365. We'll talk about that. Easy peel supports. Post-processing really is becoming really a forefront of where the advancement is coming, and whether it's done in the software or whether it's done afterwards. It's important to be able to take those parts and move them into a final restoration as fast as possible. And Easy Peel Supports is there. An industrial grade DLP chip for final detailed parts. Really, the heart of a 3D printer is in its projector and its DLP chip. The Einstein itself, it's bigger than the Asiga, but it's not a standalone unit. So it's 16 inches by 16 inches. It stands about 30 inches tall, weighs about 80 pounds. You'll notice this is about 4 times heavier than the Asiga. This thing is an all steel machine. Hyperprint. So hyperprint is utilizing what we call closed loop feedback. In all DLP printing, you have separation forces. So when the platform comes down and it pulls away from the tray, you create separation forces. Those forces actually interrupt the proper printing. You can get misprints, supports come off, things stick. And so managing those forces and those layers are key. And that's how we do that in what we call the closed loop. We have sensors that determine where those forces are and when we release that. And the thing that I think is really important is the use of our heat. So we have built-in heaters, and every single material has its own temperature. So when you go to select the material, you hit print, it automatically going to guide to that temperature to give its optimal printing capabilities. Every material has different viscosity, so we need them at different temperatures for optimal printing. This whole aspect, this hyperprint, has increased the speed of printing by twice. At least. The Envision 1 printer, which was the printer that had our oxygen technology, I went head to head against the Carbon M2, and we were twice as fast as the Carbon M2 on that printer. When we've added in heating element to this and closed loop, we're twice as fast as the Envision 1. I'm doing models in 13 minutes, vertically doing parts in under an hour. So the speed of this has really changed the nature of a 3D printer. I think having an industrial grade DLP chip is also understanding that there is a difference between one printer and the next. I think most people don't know that there are different grades of DLP chips. Texas Instruments makes them all. And there are low-level chips that are like broadcasting chips that only are indicated for, let's say, PowerPoint presentations where it makes a difference in color. It's distinguishing colors so your images pop. We use an industrial grade chip, which we literally program to things like for pixel tuning, which is one of the patents that we hold, and being able to program that DLP chip to create a much smoother part than a standard chip. So you have less layer lines that are created. Utilizing 385 technology and the light source is important. It gives us a smoother result. And 385 is a wavelength. So 385 is a shorter wavelength than 405. It is closer to the natural light, which, I mean, understand we're processing plastic in the same way we normally in the analog world did it through heat. So for example, if we're processing a denture, and for that denture to go through its heating process and go through double cross-link polymerization, we're doing that same process through a light source. So our light source is very critical, and the 385 light source is the most efficient light source. It has a higher rate of light absorption, and more light absorption gives you a higher photochemical reaction and a more efficient cure. You can see that in a night guard or a surgical guide. When you've printed a night guard, a surgical guide, and you get this is indicating that your photo initiators are not all kicked off. And that photo 405 light source is long so that it bounces around and kicks off, and it doesn't effectively not light up all the photo initiators. 385 is much more efficiently, and you get a much clearer result. When we talk about 3D printing, we also talk about the software that we can generate. And in our software, we have what we call easy peel supports. And we can adjust those supports so we get the tiniest little points of contact, allowing us for removal of the part. It also gives us a very intimate connection between the sleeve and the surgical guide. You can see it here that this has just been printed. And so we're going to be removing the support. So instead of taking a snipper and snipping each one because they're so thick, they literally peel away. And the sleeves drops in. And then when you light cure it, it's going to shrink around that sleeve. You don't need to use any adhesive. It's perfect. Any questions before I go any further?
I think there was one, Kev, I'll read it for you where you can see it. Could you please provide us with some reviews showing the accuracy of fitness of the margins and what factors are affecting that?
I don't have it on this slide deck, but we do have some studies that we've shown. And that's a combination of a couple of things. This is where, when we're building a team of our dental application engineers, when I'm dealing with a customer and they're not getting the fits that they think they deserve on the printer, a lot of it also has to go to the DME files. And we see a lot of fit that those DME files have to be geared to each printer. That's step one. So whether you have, a different mill or a different printer, your different technologies print and output that differently. So when you get a new printer, whether it's an Asiga printer, whether it's a desktop printer, whether it's a Formlabs, whether it's an 8-ite mill, you're going to have a different DME parameters and different settings for each one. That is critical. So once we do that and we dial that in, we've shown, and we've actually on this Pro XL, it's a good question because the Pro XL is exactly what we were measuring on accuracy. The Pro XL is designed for one thing: uptime and reliability. This printer really is to go against that carbon printer where you have very limited downtime and it's very reliable. On this particular printer, it is the most tested printer we have ever done. We've been testing this rigorously since November. We've just launched this in Chicago. It will be delivering in May. And on this particular printer, we did 763, and I can provide some of this data for you on the side, but publicly I haven't been approved to show it. 763 jobs where we measured at 50 micron accuracy, because the accuracy on this particular unit is 45 microns on the X and Y. The only thing you have to determine is on the Z. So 50 microns, X and Y was 45, with 763, and all of them were 100% perfect with unbelievable accuracy. We set a new bar for accuracy on this unit, but it has a lot to do with your printing parameters as well as the material you use and the printer that's there. So this unit here, some of you, if you've known EnvisionTech for a while, recognize this frame. The only thing that's similar about this unit is the frame, because we've got a true 4K projector in here. This actually fits the size and the distance we need between the platforms. So it's a standalone unit, and it has a large build envelope. I'll show you in a second. It has the largest build envelope and the most accurate printer on the market. We have dual linear slides. I think some of these little things you see in a printer is people take for granted. But dual linear slides means you've got a screw in the middle and two linear slides to keep that platform perfectly horizontal. If that tweaks a little bit, then you've got a proper home position problem and you're not going to get printing. So it's important to keep that horizontal there. Smart load sensors. This is part of the closed loop system that I was talking about, where it measures the separation forces. Easy peel supports, which is what I showed you before. Built-in heaters. And I think the most important thing is this 4K projector. It's a true 4K projector on this particular unit, which is extremely robust. And the DLP chip in here is a very powerful one for production use.
Hey, Kev, I have a question. It might come from my ignorance. You know, like, why is achieving a more efficient cure important to the overall result?
Accuracy and repeatability. When I think of a reliability, I think of being able to have as many jobs as I can without failure and maintaining the level of accuracy that we claim in our statements. You can't say that for all printers. That's not how, it's not always that way. We've been wrought in our industry with a lot of hobby type printers where you've got variance in predictability, variance in reliability, and different materials that have different results. And I think when you're looking at something that has a robust 4K projector that can emit a light that's going to be reliable and effective and efficient, you're going to get effective and accurate parts over and over again. I think that's key. You know, when we're getting into this digital journey, and reliability on the equipment is important. The future is going to be on materials, but we need to make sure that our output is the best on the market, and that we also have workflows that have been validated with materials and being able to take you through the process. All of these are important factors of having 3D printing to be an important part of your production.
Thank you.
When we look, this is a 10 by 5.5 inch build envelope. And when I compare this to the Hay gears, it's literally 3 inches bigger, almost twice as big as the Hay gears. The Asiga 4K 80, which is a popular unit, I don't think it's as popular as the Max, but it's also probably almost an inch on each side smaller than the Einstein Pro. When we look at accuracy, right here, our X and Y ratio, and just for clarity for everybody, the X and Y ratio is generated by the projector. It's one of those variables you cannot change. The only thing you can change is the Z variable. So I can go 50 microns or 100 microns on my thickness. So when I'm looking at a projector, your dimensional accuracy, 2 out of the 3 dimensions, X, Y, and Z, are not adjustable on your end. It's a part of the projector. So having a 45 micron is the most accurate for the largest build envelope in the industry. So that's important. And we compare it to the Stratasys J5 or the Asiga 480 or the Hay gears or the Carbon. I mean, the Carbon's only 75 microns. It's $157,000 and it's a lot smaller than the Pro XL. The Hay gears, smaller as well. It doesn't have anywhere near the accuracy. I don't really agree with this 75 number. I think it's closer to 90. The Asiga being one of the most popular printers out there because it's been, you know, it's been on the market for a while, and it's a pretty good unit. Also smaller with not as great as accuracy. And I think the reliability that we have put into the Pro XL is going to be greater than that of the Asiga or the Hay gears of the Stratasys. I think what's important, and this is the thing that excites me the most, are the materials. I truly believe that the advancement in 3D printing is going to go where the materials go. We have launched a material called Flexera. We have a base material. We have a Flexera Ultra Plus. We have a Flexera Smile. Guides, guards. This Smile guard here I'll talk to you about as well, and our model materials. We're also, we had signed an agreement with Keystone, so we're in the process of opening up the printer, both the Einstein and the Pro XL, to third-party printers. The goal is to open up this printer platform. A closed printer system, I don't think is going to be beneficial. If you look at the industry now, how many closed mills are there in the dental laboratory world? How many closed mills are there? I mean, we've been milling for 30, 40 years. We've been milling zirconia since 2004. How many closed mills survived in the dental lab? 0. So why should we think that the printers are going to go the same way? So we're in the process of opening it up. It is now, Key Splint Soft is available on these units. But let's talk about this a little bit. And I think when we look at what's the number one, other than models, what's the number one application that's being printed? And that's night guards and splints. 60% of dentists have seen an increase in cracked teeth. 70% have seen increasing in grinding. Literally, a doctor could prescribe a night guard to every single patient that comes out the door. So this is a very important aspect on 3D printing. What I see when I look at this grid are these down here. These are the areas that are full of growth: the try-ins, the denture bases, permanent crowns, partial frameworks. We get a flexible partial that we're working on to print. This could go from 16 to 58 if we get into the flexible partials, which we're working on. But these three numbers, or these four numbers here, we're going to see a huge increase. This is the potential. But right now, that's the number one material is the night guard material. And the Key Splint Soft has been the number one unit material that has been out there. But we just launched Smile Guard, and Smile Guard is unique in several ways. It's super flexible. I think one of the nice things about this, and people don't pay attention or even think about, is that it's tasteless and odorless. So if you put the Key Splint Soft or some of these other guards in, that patient can taste the methyl methacrylate, right? They have that taste and that smell. But the night guard, this particular material is tasteless and odorless. We've been selling this in Europe for the last 2 years. And so we've got FDA clearance. It is Health Canada cleared as well. So it's effective in Canada. I can tell you that I've done lectures. I did 5 lectures last year in the States, back to back to back. And each one of these, I brought a nice Smile Guard. Of all 5 of those lectures, there was over 50 people in each one. And as I started to talk about this program, I gave them a model with a night guard on it. And you know, when you're in a lecture and you're listening to the lecture and somebody passes around a sample, everybody takes the thing off and they're like, they're trying to break it under the table. Well, this thing went through 5 classes of over 50 people, of them going like this, and it didn't break. The Key Splint Soft, it took around before the first go around, it would broke. So this is a pretty durable material. It has that same kind of softness that the Key Splint Soft has, but we built in toughness in this particular material. Just some testimonials. Here are some of the flexural strength numbers on this, the 1100 MPAs for flexural modulus. This is the number that is going to represent how well it bends without breaking.
We have a question, Kevin.
Yeah.
Does your company have an all-in-one print like Stratasys, denture base, and tooth color all-in-one print?
Nope. This is it is a vat polymerization, right? So you're only able to put one type of material in. Stratasys uses the inkjet technology, where they actually have different colors, like a regular inkjet printer, CMYK, right? And those colors pull based on their computer technologies, and able to inkjet that material out. We have one vat of material. You can only have one color. So the characterization really comes in with post-processing. So different technologies allowing to do different, I'm going to go right to Flexera. I'm going to skip the video. Because Flexera and the base material, this material is probably the #1 material that EnvisionTech has ever invented. We were selling this material as called EDEN 1000 as early as 2018. So it's been on the market for quite a while. We were purchased by Desktop Health Metal and became Desktop Health. So in early of 2021, we rebranded this as Flexera. It had gone through some formula changes before 2021, but now is considered one of the most #1 materials for creating dentures and all-on-X hybrid provisionals in the marketplace. I think it's interesting is one of the reasons why is let's take a look at what has been in Gen 1 materials, right? Gen 1 materials are NextDent, Denka, DTax, Dreve, those original materials that you were printing your dentures out of. Those materials, and I know a lot about the NextDent because we sold the NextDent through the Envision One, and we were a distributor of the NextDent material. Very good material, by the way. But those earlier materials were basically simple acrylates, like a guide or a model. These simple acrylates that we colorized and made a little stronger to print. When we look at what we've always looked to for strength, which is flexural strength, right? When somebody asks you what's the strength of a material, you immediately go to flexural strength of that material. It's what we've been taught to do for all of these years. And if you do that in NextDent or in Denka, you see that their flexural strength of that material was 85, 89 flexural strength. If I take a low impact material like Fricky press pack denture acrylic, right? That material has a flexural strength of around 80. So your flexural strength in press back dentures range from 80 to high impact denture material, which could be 150, 160. Those are the ranges. And if that was acceptable, then the Denka material, the NextDent material, all of those would be acceptable as final restorations, and they're not, right? Why? Because that's not the problem. The problem isn't the flexural strength. The problem is the modular strength. It's the flexibility. It's the ability to withstand the load it takes, that appliance takes without breaking. That's a different test. That test is work fracture modulus. Work fracture modulus, joules over meter squared, the energy it takes before breaking. How much a load can that take? When we look at that test, in this work fracture modulus test, which takes a sample, it puts it in water, 37 degrees Celsius for a week, and then we instigate a crack before testing. So they snip the sample and then put it into a load, and then we determine the strength of that. And where does that break? And that breaks, my friends, are 3 times greater than the Lucitone material. This is why this is the #1 material in the United States for dentures. Now, that's impressive. So we're starting to, that's why these are all on X provisionals are the #1 material for that case. And looking at another factor as well is moisture resistance. The moisture resistance on this is important because we've changed the chemistry of how we're making these dentures. And by changing these chemistries, we made it more water resistant. And so now we go through these water absorption tests, we are taking half the moisture resistance. What we're seeing this clinically is that when you do a hybrid provisional, you put a denture in the mouth and you come back and recall it 3-4 months down the road, you're not getting bacteria. It's not staining. And the first time we saw this was in 2020. One of our administrators flew from Michigan to Dunlop's office in California, had her case done, immediate load, immediate provisional. She had her surgery done, came home with the Flexera hybrid in June of 2020. She didn't go back to Dunlop's office until September of 2021. So 15 months it was in her mouth. She smoked 2 packs of cigarettes a day. She drank coffee, and this shows no sign of staining. That has a lot to do with the moisture resistance. That is the key effect of that study. I think the other thing too is the third piece of the puzzle is wear resistance. And that when we look at a study like this done at the University of Alabama at Birmingham, which has the most, it's probably the most used wear equipment that they have in the highest level profilometer, that this has significantly less wear than Lucitone, than Sprint Ray On-X, than its competition. So we are demonstrating 30% less wear than what's already existing out there.
Okay, question time.
Yep.
Is Flexera certified for long-term use, 5 years or more with Health Canada?
The answer is no. We launched Flexera Ultra Plus Smile in Europe and through the FDA in the United States, and we got clearance for permanent crown restorations. We submitted to Health Canada It is good for temporaries, but it did not pass because it wanted the additional 5-year clinicals that you just mentioned. So Canada is making us go through some more testing, even though our testing has passed the FDA and CE. So that's where we are. Unfortunately, you will see Ultra Plus Smile in our product portfolio. You will notice that it is a permanent crown restoration solution. It is with the FDA and it is with the CE in Europe, but it is not a permanent restoration for Health Canada. Does that make sense?
Another question, Kev, is what about hard card? Because the soft one is used just for acute causes for a short period of time.
That is part of our validation with Keystone. So we've created a partnership with Keystone. We're going through validation and we're going to validate the Key Splint hard for these as well. So that'll be an answer for you. Does that make sense? Is that good?
Yeah. Thank you.
Perfect. So when we talked about marginal fit, we had the question earlier on, do we have studies? These are some of the studies that we show on crowns on marginal fits. We got more data that you wanted, but this is what we're showing. And we're looking under 385 light sources. It's not hitting some accuracy. So we run this tolerance using Three Shapes convinced software to determine the tolerance on this material. What we do differently in the Flexera is we create a longer chain chemistry. So imagine you have acrylates. We use oligomers more than acrylates, and having these longer oligomers with more open carbon atoms allows us to give a tighter cross-link polymerization. And as I was saying, light source is an important part because we're typically used to press packing or using heat or chemistry in the form of cold cure to create this polymerization. In 3D printing, we're using the light source, and our chemistry matched with our equipment gives us the result that we want. Workflows are important, and I think having validated workflows with a validated printer and a validated material are going to allow us to keep consistent results with our system. Here's an example of an Instron load being done on a competitive material here. When I hit play, nothing's going to happen, and then you're going to see the thing explode. And then the next part is going to be the Flexera, and you'll see that it takes a lot more of the punishment. And here's the Flexera. It's able to absorb that energy without breaking, and then it returns it back itself to full memory. Let me run that again.
One comment on what they're seeing is, that is great. Go on.
All right. So it's showing evidence. I think aesthetics are key. I mean, we can have the strongest material in the world, and if you take yourself back to 2004, 2005, 2006, when zirconia was first being milled, that was the problem, right? It was like, oh, it's too white, we can't cover it up. But it wasn't metal, it wasn't gray, and it was lighter than the alloy. So, but over the course of time, right? You take 2004, it's the zirconia journey all the way to today. And today we have amazing translucencies, 1250 megapascal strength, 5-layer pucks, right? You're going to see that same journey in 3D printing. And so as we increase the strength in our Gen 2 material, and we're going to be launching a stronger base coming out in the summertime, and we're going to be launching a highly ceramic, over 50% ceramic filled Flexera for permanent crowns as well. but to institute optimal translucency is key. So we're adding in as much aesthetics and formalizing this to be as optimal and aesthetic as possible. That's how they fit. Beautiful. So we have 6 shades in the Flexera, bleached A1, A2, A3, A3.5, B1, and we've got 5 shades in the base. We've got our original pink, which is pretty close to Lucitone. I think we're also working on a color that is going to be even closer to Lucitone, because Lucitone color is obviously the standard. There's been over 100,000 dentures. Like I said, we formulated this thing back in 2018, printed to date. We're putting together courses where we're going to make sure that workflow goes from software design all the way to post-processing. We're going to start harboring some of those workflow courses. But this is really, I think, the focus. Here's a crown that was done out of Flexera. It was an onlay for Dr. Wally Rene himself. You can see that the marginal fit of this is really amazing, and that it blends so nicely in with the existing dentition. Another case was done for the Flexera Ultra Plus. Now, Dr. Wally Rene and some of those in that clinical space, they do dentures, they do veneers either direct or they do ceramic veneers. In a lot of instances, the ceramic veneers are way too expensive for the patients, so that they're using Flexera Ultra as an economic solution in place of the ceramic veneers. What I see here, it being in the dental lab space most of my life, is a very nice looking diagnostic wax up, where you can print it, polish it, send it to the doctor, let them put in the veneer case. The patient can put them in temporarily, wear it, go show their spouse, go show their family, and then come back and sell a $10,000 ceramic veneer case. That's what I see. So it's a great diagnostic wax up tool. You can characterize this using OptiGlaze, Vita's characterization, and Extent. Any light cured material characterizes quite well. This is a recent case that was done. So I'm not sure if many of you know, but Desktop Metal also bought a group of laboratories, the Dental Arts of Peoria. So we manufacture many 3D printed dentures that go in the mouth all day long. This is everything that we do is done commercially by us before we leave launch into the market. So this isn't just the ability to do one and get a nice one done. We are literally doing this on a daily basis. So this particular thing has been completely put together, but it hasn't been polished. You can see some of the supports that were on here. So it was basically printed and put together. Here's another image of that same denture, printed and put together. And here it is polished. So it's just a simple polish and Ivoclar polishing paste, and it was characterized using GC's OptiGlaze. So the hybrid here was done using the OptiGlaze as well. By the way, these were characterized and polished inside of 15 minutes. This case was characterized in 20 minutes to do this one, I was told. So those are finished Flexera cases. Just understanding what the speed of some of these prints are. Your Model Z, I can print 6 models in 13 minutes, 32 quadrants in 48 minutes, 6 surgical guides in 31 minutes. I can do 112 crowns in 28 minutes. So we do have a high level of speed to print in a lot of different applications. Finishing up here, here's 9 denture bases printed in an hour and 35 minutes for $9 US. The night guard, smile guard, I can do 6 guards in 30 minutes for a cost of $5 US. E-guides, again, similar speed. You know, your models here, $1.65 US. So that concludes my time. I was trying to be within my time limit. I hope I did okay.
You sure did, but before we let you go, you got a couple more questions you gotta answer, big guy?
Got
Okay.
it.
Okay, so let me ask this one. Can patients soak the denture in denture cleaners overnight? Can we easily repair and reline with regular cold cure material? That's one of the questions.
All right. No, the answer is soaking the dentures overnight is actually a contraindication. We just want, and we have a patient care card that we're gonna put with every Flexera base. But they should be brushing this with toothpaste, washing it, and then putting on dry. So do not soak it overnight. Yes, you can reline and repair it using, I think one of our clinicians uses the Bosworth reline material. I've got the exact material that I can share with you if you email me as well. So actually, let me throw my email on here.
Yeah, put the email. Hey, Kev, I have a question. Like, who's representing Flexera now in Canada? I know that you had, is it direct or you have other people?
We Emerald Dental, Proto 3000, and Henry Schein are our dealers in Canada.
Thank you. One more question.
Yes.
Is there, this comes from Deepak Naik. Is there a BAM, body activated material factor in Flexera, which may help to better adapt the denture bases to the basal seat tissues, especially with ongoing residual ridge resorption?
Absolutely. That is literally the secret to both the Smile Guard and the Flexera material. As it warms up, you can soften it. In the time I put this in my hands, this night guard that I'm holding, I can actually bend this in many different ways. And the warmer it gets, the more softer it gets. Which is why we want to, be careful with heat. When we're post-curing this, it requires 3,000 flashes with the auto flash, and then turn it over and do another 3,000 flashes. In between there, we're going to let it cool down because it gets hot and you can see it'll soften a little. So in the mouth, the body temperature allows it to kind of settle in and gives it some comfort level there. Absolutely.
Yeah, what can I say, man? I would like to thank you for sharing your vast knowledge, the latest things, and keeping us informed, our group informed, and in the cutting edge.
Thank you so much.
We want to bring you back. Maybe we should do some hands-on together when you guys are ready. I would love to work with you, you know that. But I love it that you're willing to share your knowledge. Of course you represent the company, but it's a reality. And I just love it, whenever you start showing the figures, because I'm not a dental guy, but I understand finances, I really like it. Okay, there's a commentary goes, thanks for this great information. Of course, it's the latest and we really enjoy it. So I thank you on behalf of our group. These guys are special guys because, they're willing to invest their salary to improve themselves. So I love them, and we had 155 register, 112 came in because the other guys from the other provinces, they like to see it on demand. They want to sleep in a little more,
Of course.
Yeah. So, but anyways, it's terrific. Hope to see you at Spectrum Day Toronto or the other Spectrum Days, but let's keep in touch. Okay, brother?
Absolutely. Thank you so much. I really appreciate being invited on here.
Yeah.
So have a great rest of the day, and I appreciate you. Thank you.
Yeah. Thanks, Kev.
All right.
For you guys, just a reminder, guys, there is the next one. The next course is in May 6th, which is an SDA, but we have a TIA next Wednesday night. If you can register, it would be good. I'll send you the emails anyways. I would like to leave with another thing, before you guys go. We're preparing already for Spectrum Day Toronto. Usually Deepak is a good friend and mentor. So Deepak and Carlos Zanon and Joe De La Marina, they step in because these guys realize I'm not a dental guy, and I think they feel sorry for me. So they want to help. But I tell you, we had huge success, and I love to share success. Yesterday, I think I told you at the beginning, we had a women in dentistry symposium. and we had over 300 women. It was unbelievable. So we have huge momentum. But, you know, somebody texted me and said, what about artificial intelligence? You know what? From what I could gather from the IDS, okay, guys, artificial intelligence is gonna be, you're using it already. You know, anything you do Bluetooth is artificial intelligence. But the way I see it is that artificial intelligence is gonna use, okay, to systemize the technology that already exists. So it's like a, you know, a Google, say, hey, Google, wake me up at 6. Okay, so it's systemized, you know, the alarm will go on then. So, but again, I would just like to repeat, you know, like how happy I am, you know, like, and how proud I am that you guys are willing to invest in your future, because that's what you're doing when you're listening to these courses. It makes you think anyways, and you challenge the speakers. This is great, you know, like, and it's good for you. So again, you know, like, enjoy the rest of the weekend. Keep in touch with us. Let us know what you think, what you would like, either for next year SDA. We're planning with, you know, I'm gonna mention this, Deepak. We're planning with Deepak to launch a contest for George Brown students, third year students. And guess what? Some of you guys are gonna get involved. You don't know yet, but you're gonna get involved in judging what we have. And then we'll give them a nice prize. And my goal is that eventually bring the school from Quebec, and then bring Nate and make it a Canadian thing, and really propel the knowledge of the Dentures profession, you know, like, not only in Canada, but because of my network all over the world. So anyways, I wish you guys a great weekend. Again, thank you very much. And we'll talk to you soon. Ciao.